Hello everyone, and today we shall be discussing about online code judge system design. Now, something that I want to discuss about over here is like first introduce you guys to what online code judge is, and then also discuss about different components of online code judge. Now, to my audience who might not be aware of it, you must have heard of these terms. For example, Leetcode, HackerRank, Code Forces. Now, these are something that, in case you are living under the rock, then maybe you guys don't know about it, but they are responsible for you practicing your code submissions logic, or also they have a flavor called contests. So in the next part, I will be saying about what these look like actually. But mind you, I'll be focusing more on the lead code one. But hacker rank code forces, they also kind of follow the same aspect. The interesting part will be the contests that we will be discussing in our system design. But overall, let's take a look. So as you can see, there are problems over here, and then there are some examples, then there are constraints, and also then there are hints topics. Now these are not the main concerns. These kind of things depend platform to platform. The main thing is you can see the problem and description, and then in the right side you can see that you have the choose language which are as of now supported by Leetcode platform. Then you have a blank template and you are supposed to fill in the code details over here. And then finally, you have some sample test cases over here. And you can add your own test cases. There are two variations to it. One is the run and one is the submit. Run is against the test cases that you already have over here. If you want, you can also add some more custom test cases. Like you just have to add your input and output, or you can even remove the test cases. You can test against it for debugging purposes and to understand where your logic might be wrong. And finally, you can do the submit aspect. Submit means there are multiple hidden cases also these platforms have, and your logic will be finally evaluated against all the test cases that the platform supports. The main condition is that it has time limit expectations. It is giving you beforehand that what is the input criteria and output criteria. And this is how like all the online judges kind of behave like. I hope this overall explanation was fine with you guys, because I kind of believe that online judge as a platform is something that everyone is aware of. Something else also is that you can have a look at all the problems that the platform supports. You can kind of search whichever problems you want to look for. And obviously, there is also the contest aspect of it, because I have not registered in a contest. I will not be able to show you on this particular dashboard. The altogether discussions that we are going to have for the system design, the initial part would begin with the functional requirements, or which we also say as the business requirements. And for that, I kind of gave you a brief walkthrough of what something like Leetcode looks like, and we'll be exhaustively discussing about taking this as a base medium, but then it applies to all the different online judges that I have been talking about. I will be talking about different scales also of this. So let's get back to our drawing board. Now that we have seen a glimpse of how online coding judge like Leetcode is, let's pin down our functional requirements. Knowing functional requirements as well as coming to the non-functional requirement part gives an overall idea and brief about what we should be expecting in our design. And it kind of is necessary. Like obviously a mental model is already formed, but when we are pinning it down on the board, kind of makes our life easier, because then we know that what is in our scope and what we really don't care about. There can be a lot of different things related to a product. We are only concerned with these particular XYZ things. So if I were to say about my functional requirements, I will say first of all, view list of coding problems. I would next go for supported multiple languages. For supported languages, view particular problem. I mean, it can be turned other way around. View particular problem and code in supported language. I know this time I'm writing in a weird way because I will finally condense it down into beautiful bullet points, but first I will be writing in kind of the way I generally think. Now this would be submit code for the supported language and get instant feedback. Now what is instant over here, we will quantify in a couple of minutes, which will be part of our non-functional requirements, because functionally we just define that we want to get feedback instantly. Like while we have submitted our code, we just want to understand that hey, is it like success, or is it like TLE or compilation error, all those things just we want to get to know. I would also add something to it. Submit code has two variations to it. One is run with few test cases, run all test cases. This was the one that I had pointed out to, that there is a run button and then there is a submit button. Finally, we have two more. One is user to register for competition, and the other one will be should be able to view live leaderboard. And again, what is the metric of live over here? We will come to this as part of a non-functional. All of this I would say is functional requirement. Obviously the handwriting over here is not clean. I will just take a pause and kind of write it more cleanly, but this is what comes under a non-functional aspect, the instant part and the live part. But a certain thing is we are submitting here code. A code can be of highly vulnerable nature as well. Why? Because we can put any kind of exploits. We can put a while loop which keeps on running, and that will eat up all the resources because this loop will continuously run forever. So there will be another sort of non-functional requirement that we have to run individual code in isolation as well. So let me just clear this space and then we'll go forward. There we go. Now it's looking much better. This part on the left side is our functional requirements. Let me just draw one line here. And in the right part, I will be discussing about the non-functional requirements. So I was talking about these particular things, which we kind of differentiate between our functional and non-functional. So it's not like differentiation. It's more like quantifying what we should be trying to say. First thing is what do we mean by live? One is what do we mean by instant feedback? And also things like the security concern of the code that is being run. So let me write those down as well. And this is what I was talking about. You guys can take a pause on the screen and read it carefully. But again, main thing was support isolation security when running the code. This instant feedback we are targeting within 5 seconds we are able to get the results. And for the competition aspect, I'm saying that scale to support around 100,000. Like this is our target number. 100,000 is a lot of users for a competition worth 90 seconds. 100,000 users are live and they are able to see the leaderboard live. And live I'm not quantifying directly because there are multiple flavors to it, but if I were to give a number, I would say within 2 seconds they are able to see leaderboard status like rank. So let me write that also down over here. I don't want to quantify it, but still view rank in less than 2 seconds. And there we go. Now comes the exciting part, because we have understood overall what is being expected out of this online judge system. Before even jumping, like our next step would be thinking about APIs which kind of satisfy all of these different functional requirements that we have kept, and then coming on to the system design itself so that we start supporting our non-functional requirements. But before that, I want to lay out or list down some important things like the problem itself. Why? Because understanding what problem consists of is one is the question, one is the input test case. In that also we have like visible and hidden. So out of let's say 10 test cases, 3 I will make visible and the rest of the 7 would be hidden. For say when there are 10 test cases. And what I want, which test cases I want to make visible and which I want to keep hidden, completely depends on me as an admin. Then the next would be my expected output. Why? Because I as an admin am creating these test cases, all the test cases. So I know that what will be the exact outputs for it. And because I also know that what is the exact solution. There's no exact solution to it rather, but it's more like if I am the one designing the test cases, I will be the one who has to provide expected output. And then comes the next part, submission. So in submission, there will be my code, like user's code. It will be in a particular language. And now from this aspect, whatever code is submitted, it will be run and against these test cases, and an output will be generated. These output and the expected output will be compared. If there is any like test case 1, test case 2, test case 3, and output 1, output 2, output 3, if any of these outputs are not matching to the expected one, so O1 expected output 1, EO1, O2 expected output 2, this is compared to T1, now this is equal, this is not equal, then we will have to accordingly give back the results. So I will mention the result part here as well. Result status, or I would say the status of the submission. And finally, we have the leaderboard aspect for competition. So let me write in parenthesis for a competition. And then we will be saying that we will want to look at rank, like it will be top 100, top 1000, and my rank, specifically like where do I stand, these things. Obviously competition will also have submission, so they are kind of intertwined. But now having said all these, it makes more sense to now discuss about API. Generally I kind of take, like there is no fixed pattern to it. It's more like if in case I think that I have to talk about certain aspects, then I talk about it before jumping to the API, or rather I can jump to the API and start discussing about the same, because I've already mentioned a bit of structure over here. So in the API, it will make more sense. And in this case, I am actually trying out a new style of writing an API. I will be shifting now to the Excalibur whiteboard. There, it's more easier to write using my keyboard, and then I will copy all those things from there into my drawing board. So first, let's discuss with, I guess, the main aspect, getting the problems. This will be a normal get request, and then it would be something like problems, and our path parameter will be problem ID, because each problem will be uniquely determined using its problem ID. And the kind of response that we should be expecting, it would be something like the problem ID itself, then the title of the problem, description to the problem, examples, what else, constraints. In this case, it's so pretty straightforward that once I'm laying down the exact parameters that will be getting a response, it's also like a mirror when I will be designing the schema of the DB itself. So I will not be taking much time over there. Now there will be the difficulty tags, like this would be obviously an enum. I'm writing over down here, enum of like say easy, medium, or hard, like the pretty much same thing that you see in the UI. And then the tags and acceptance rate, like how many acceptance or percentage of accepted submissions have happened over it. And then starter code template. So this is based on your language. This would be like your another array of objects. Like there would be a code language, and there would be your say C++, and here would be your template code. Or you know what, rather I will kind of change it. No, actually this is correct format. The main thing was I should have written here template code, and then I was writing, and then kind of I won't be writing, but let's say some gibberish. And similarly, we can kind of, let me just give them indentation. Okay, do I have to? I do not, but kind of makes it look much beautiful. And here we can give, and we can expand. Yeah, so this is fine. Get problems, problem ID. Then we'll also get, so when you see in our lead code, let me open it over here and check that when we change our problem, so we also see the code that we have already written. So in Python 3, if you see, I think in Python maybe, yeah. Let's say I would have written some A, B, C, D, E, F, and I go back to C++, and again I come back to Python, then I am able to see this. So what is happening? So there will be another API call where we are getting to see if, or it's not an if, it's more like we are getting to see that what code has been saved already. So we will be writing it in this way. Yeah, I will be continuing it over here, get with problems, then a problem ID, and then the resource that we are asking for is the submitted code. Then we will have the languages, then the language ID, okay, and then the sync code. Basically, this is the exact way how we create our resource structure when we are writing these kind of REST APIs. Our verb is get, and then problem, obviously pinpointing for this particular problem ID and what language we had already chosen while writing the code, and then exactly the synced code part of it. And the response would be something of this format. We'll be seeing problem ID, then we'll be seeing the lang. For example, in this case, it will be CPP, and then the synced code. This will be looking something of this format. And a timestamp. I mean, this is what exactly see in the Leetcode as well. It keeps updating time to time, so there will be a timestamp, some Unix style, and then we'll have the exact code. Not going into that, it will be some gibberish, but you get the point. Here we have all our problems. Now the next part would be when we are submitting a code. This will be pretty interesting. We'll be doing a post with the submissions. Sorry for that. And there we go. The main thing would be the body of it. Body will be having the problem ID. Then we'll be having the lang. Then we'll be having the code snippet. This would be a string. And finally, we will be having a contest ID. I think not only contest ID, there will also be, yeah, let me scroll up, and there will be test cases. Test case. Actually, you know what? I think I should be making one change over here. I need to, or I should, there are both flavors of it. I will kind of go with this flavor. This makes more sense. Why? Because one is for the given problem ID, I'm making a submission, and one is interpret. This I'm directly picking from the API calls of what Leetcode does. Here we pass the code along with, there is no contest ID for it. There will be test case, and it's not even test case, it's more for data input. And it will be like a string. So what I have literally seen, for example, you want to kind of mention your array. So you can do it in this way, 3 to 9. And let's say your output would be something of this format. Let's say output is 9. And then you have another new line. And then you again have 3, 3. All of these are basically a string literal. It will be kind of digested. Then here your output is 1. I don't know what that exact problem is, but let's say this is your particular data input. Here will be your particular code. And again, here, let's say we are passing CPP. And then we really don't need to pass problem ID over here anymore. Or if we kind of take out the problems and problem ID from here, then we'll be passing problem ID over here. I want to kind of keep it in this format. So I will be taking out problem ID from here. And I'll be just copying the same thing. But now I'll be creating a submission concept from here. So this I will keep as submissions. You know what? Rather, because eating up space. So I'll cut it from here. And I'll create another text box over there. There we go. I guess somewhere here. Yep. And yeah, if I keep it over here, and now in submissions, I again lang code. Now data input is not at all needed. All my input will be coming from the existing set of test cases that I already have, and it will be compared against the test outputs that I've already written. So here will be my logic. And obviously there will be a contest ID as well. Because I mean, submissions, you can now generalize this API when it is part of a contest ID, it will be filled with a contest ID. In case it is not, then it will be null. So this I am putting question mark because it can be empty, it cannot be empty. Now the interesting part is for both the cases. Oops, the response. Let me just write the response structure here. It will be something of this fashion. And also, generally, I don't go with response, but here it can be 201 or 202 based on the flavor. We will discuss about it in our system design. 201 is basically when a resource is created at the server side, and still it will take some time. And 202 is when the response has not been created. It's just saying that I have taken and accepted your request, but it will take me some time to respond back with a solution. Generally, we will be having a 202 in this case. So let me just take out that from here at this point. We'll have a submission ID, and we will have a status, and we will have a queue that. Now, to get the exact submission to it, what our system would be doing is doing a get call. I think I should write it in a new place. Makes more sense. And yeah, I mean, that is also one of the reasons why I kind of hate or like Xguider. I don't know at this point. It is something new I am exploring. But anyways, the main concern is we will be doing a get request, and we will be asking using the submission ID that status and the submission ID. I'm not going into the exact response of it, or maybe I should. What I will do is I'll change the resource name over here, submissions. And yeah, rather a better way would be to write it in this format. Let's think out loud what it could be. Obviously, we will be having the submission ID over here, then the status. What a typical status would look like, I'll keep in brackets. Completed pending, because I'll be coming to it, but you guys will be understanding slowly that because it's a 202, that means our browser will be doing a continuous polling. And initially it will be pending, 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 and finally when it's completed, it will be converted into status as completed. Then we'll have a verdict. Verdict would be accepted, rejected. So again, these are not actually array. These are more like different options that we have. TLE, compilation error. Sorry for the typo, but there we go. Then we will have some numbers over here, runtime millisecond, memory in KB, test cases passed. This will be the number of test cases passed. I'm not going into the nitty-gritty details over here. Then the runtime percentile. Basically, you see a histogram type of graph where we get to see that, like if I were to draw it in this way, yeah, you generally see different, and then you see your indicator over here that you are in this, like you are, there are like 10% people who are kind of slower than you, and then there are 89% of people who are faster than you, and then there are 1% of people who are as per you. So that is the runtime percentile that we are going to have over here. And let me just quickly rub out this mess because this is not a good diagram. So where was I? I was kind of here. Let me convert to my hand diagram, and then we'll be good to go. You know what? Let me just bring it over here. And yeah, now what are we left with? We have completed most of the part. The only part will be now the get contest leaderboard. So let me kind of go below and write this part out as well. Get, then there will be our contests, and then there will be our contest ID resource against which we are doing the query, and exactly what we want for it, the leaderboard. So the particular, and obviously some query parameters over here that will be coming is the page, the exact page number. Then we'll have, let's say, 1, and then limit is how much we want to see, because there are 100,000 users. Let's say by default we are keeping 100. And finally, another query parameter is around the user, because we'll get to see that exactly around which user we are doing. So if it is around me, because there are variations to it, when I'm searching my rank, I want to see 5 above me, 5 below me, not only 5 above me. Like I want to see around 50 people above and below me altogether, 100. Like this number can be changed, and that around the user is my user ID. And our typical response will be something of this format. There will be rankings array, and a typical object in the ranking would somewhat look like this. And yeah, this is why I don't like, because it by default does not give out of the box beautification of the JSON. Rank, user ID, the username. Then what do we have? The score overall that we have scored. Problems solved. This would be a number of problems solved. Then we have penalty time. This will also be like an integer. Penalty time in minutes. This is your basically ICPC style ranking. Now, what I do not want to spend much time over here at this point. So finally, we will have Apart from rankings, right, we'll have multiple objects over here, and then we have total participants to get to understand how many people are there in this contest as of now. And last refreshed or updated, this will be a time stamp or Unix style. So there we go. These are overall all the API calls that are needed. The next thing that I will be discussing about, just because I have taken some time this time on the API itself, on the schema structure design, because at the end of the day, all of it is coming from a database. I'm not going directly into what kind of database it is, but rather more like if it is a database, then how would the schema structure look like for each of the individual entity items. So here we go. Some main things to note over here, like the problems, test cases. Problems is the main, one of the important tables, the leading tables. Users, obviously, because there are multiple users in the Leetcode or in your online judge. Then you have the contests, and then you have contest registration. So basically, contest is one which admin floats, like he says the exact title of the contest, when it will start, when it will end, what kind of scoring type it is. Because there are multiple formats, ICPC style. Then there is your, I'm forgetting, but code forces. In code forces, when you go, you see different scoring patterns. It has been quite some time, like. Since I have been in these contests. Okay, like avoiding it, there are multiple scoring types, like two are very important ones. One of them is ICPC format, where you have penalty calculation, and another is a generic one. I will, when it, I remember about it, I will tell it over here. Next is the created by. Then you have your contest registration. Each and every user comes and registers to the contest. So you see 1:n mapping over here. Similarly, 1:n for the users as well, because multiple users for multiple contests, and for one contest also multiple users. So that is how it is going. Submissions is the most critical component over here. Then obviously synced codes. I will actually come to one aspect. There's a problem in the synced code. When I was writing it, then only identified. I knowingly kept this problem over here, but let me first explain. So notice in the problems first what kind of things I'm keeping over here. One is the title, then description, difficulty tags over it, time limit, like under what time limit it should be solved, the memory limit, all these constraints. Then when it was created from admin side, timestamp. Then is it premium or not, like because we have to do gatekeeping for earning money. Then the code template, JSON binary format you can keep. Now coming to this format. For a given problem, you have multiple submissions. So you see over it, this submissions, it has user ID, it has problem ID, and it has contest ID. It kind of a particular submission or entry into the submission table. It will be used, like it will be coming from a user. It will be for a particular problem, and it can be like the little question mark. It can be for a contest. It cannot be for a contest. This is like what we say in typical terms, a leaf. Why? Because you see here, this is referencing. It is referencing in all the places. This is referencing to contest. It's referencing to a user. It's referencing to a problem. And ultimately, this is the table which keeps growing, like I cannot say it exponentially, but this table will keep growing a lot. The reason I was focusing on saying it was a leaf is because at this point, I will draw a bit of a glimpse of how it might look like. All the requests which are coming, it has to hit a DB, and you have to return back like the problems and also let's say the solutions, like obviously not a solution, but rather the saved code. Most of the things are coming actually from the DB. Mainly it's the problem that you are referring to, and the test cases also generally you have to bring up. These will not grow, like the number of the size of this is equivalent to the number of problems that exist in the universe of Leetcode or any online judge. So this is very much fixed. Also the test cases are also similarly fixed. Yeah, it might grow a bit, but then again, coming to how we are storing the test cases, they will be like a bunch of for example, I had said earlier 1, 0, 2 and all these things. You will be storing it in a file, and then you will be storing it in S3, and then you will be putting it into the input path and output path. So this is the input test case and the output test case. So this will be the S3 path in both the case. Same goes for the submissions, the code itself here. So you are storing it actually in your S3, and you will be keeping the S3 path over here, path URL. And that is why I said that this actually is not correct. It's not JSON binary. It's more of S3 URL. So this will be kept over here in the synced code anywhere, because think about it, when you are keeping a size, you want to keep the size of the table as small as possible, and the bulky part of it is the code only. It will be in the order of few KBs, because like in C++ itself, when people do competitive coding, they put such huge optimization code stubs and a lot of function calls internally that it easily, because you are storing it in form of strings. In case you remember, I am passing in JSON as a string each code. So string means one character is equivalent to 1 byte, and the moment you go from 1024 bytes or 1024 characters, it's becoming 1 KB. And that is where you start bloating unnecessarily. So you keep all of this in format of file in S3. That's it. Now, even in S3, you want to keep it as file, or you want to keep it as text of files, or like, sorry, a file with multiple texts crammed up together. That is completely a design decision for speed optimization. We really don't want to deep dive into, because it doesn't affect. The main thing is the submission. Again, it will grow. Why? Because one user can make 5 submissions to a problem, and there are 100,000 anyways on one contest day doing multiple submissions, and over the year there will be like, it will go towards order of 10 or 20 millions. And that will be in 1 year, this submission amount, and you are storing it year by year basis. So this is the problematic node. Now again, from this design where I have already kept it in table format with primary key, so most of these will be actually happening over a SQL table, but we will be coming to this submissions table and thinking that how we can do it. Should it be in a SQL or should it be in a NoSQL? Actually, interestingly, it can be done via both the formats. Recently there has been talks about how ChatGPT is able to manage all of it using a master node of their, like the primary of the PostgreSQL. So even in their case, it's not submissions, it's more like the chat content itself is getting stored, which mimics the behavior of submission. So it's today at this point when you have Postgres with a high power, you can actually do it, but I will be talking in different terms, like if you were a startup, or let's say you are the CTO of that startup, what decision you would have taken. Because to do it eventually into a Postgres, you need a lot of knowledge base and a lot of other different things. So if you don't want to go via this path and you want to keep things easy, maybe you will take a NoSQL. What advantage you will get? All those things will be part of the discussion of the system design that we'll start discussing about. Given, you can take a pause at the screen, you can again go through the different columns of these tables, but it's not necessary that submissions has to be a SQL table. It can be a NoSQL table also. I am revealing some part of the secret right now itself, but I'll again discuss about it. The main thing is when any of you guys are also designing, so you need to see how many gets and posts are there. Most of them we all have here are gets. So to point out that we have so many gets, like we have 4 gets over here. The system is pretty much easy. The only part happening here is this post, and both the posts are same. It's actually the submissions, but written in a different style. So if I were to quickly give a brief glimpse of how the design would look like, which I will now, or the interesting parts of drawing blocks and arrows, but honestly speaking, blocks and arrows are not actually so interesting. Now even I can say that these are not so interesting. It's more like if you have nailed it down properly to the API level and what schema structure is there and which is scaling or which is growing very much, then you can keep playing around making different components like Kafka, Redis, services, microservices, everything. We have our happy user over here. They are making a request. There will be obviously an API gateway and load balancer in picture. We have to fetch problems, so there will be a service which kind of takes that request and reaches out to our PostgreSDB, or we can say it a SQL. In this case, I will directly name it as PostgreSQL, and it will reach out to, and it will just give us the problem with the problem ID. Now, next thing is if we have to even get the language itself, get the synced code also. Again, the same path. Another API request will come over here. It will go into the PostgreSQL. It will resolve. Okay, so for this particular problem, it will be going into. So now at this point, there will be an S3 as well. Let me draw. Actually, let me cut this entire thing. Give some space. Put an S3 circle over here. Blob storage. And it will reach out to S3 as well. Basically from here it will get the schema structure, and here it will be the synced code S3 URL. Let me just change the pen color, and yeah, the S3 URL. So here we will be, in our service, will be resolving the code from the S3, the code will be bringing over here, and from the Postgres the remaining metadata, and we will be resolving it back to the user. The main thing is the submission. Now, when you are submitting, and again, quote unquote, this is the interesting part of the Leetcode along with the leaderboard design. Here, when a person submits the code, for example, the code snippet that we are getting over here, where is it? The one that I'm talking about here, or even say here, you have to pass it. So at this point, create a new service. I have not named a service, so here I will name it. It's not problem service, but for now, let's say we name it as problem service. Some better names should be thought of, but we can suffice it with problem service. Here, this is the submission service. The code request that comes over here, there's a reason why I have named it a submission service. The way it needs a scaling is not similar to the way problem needs a scaling. Actually, to be honest, most of the questions that are coming, you can even put a CDN over here, and you can put it over here. But I will be introducing this block later when I will be fixing most of the components of my child. Let's not go in different directions or like the breadth first concept. I will be going DFS from now onwards. Here we have our submission service. Now, as we already have understood at this point, there are multiple submissions coming. Now, there are two things. One is a normal scenario, and one is your contest day or contest event. We have already said that in contest event, we are supporting 100,000 users at a given time for 90 minutes. And when a contest duration runs, the first, I would say it kind of, there is a phase in it where the last 20 minutes, or I would say the last 10 minutes are the most crucial. All the submissions are happening at this point. 100,000 users is equivalent to 100,000 submissions obviously happening. In the first 5 minutes also, there's a similar search. The master or those who are very expert in the contest, they will be searching. And here there will be an eventual load. And that number will be around 100,000. Dispersely coming, like here you can obviously say that the load will be around 1000 RPS, and even here there will be 1000 RPS. So for submission, we'll have to scale this service independently. But for every submission that we are doing, where will the code run? That should be the main question that should be running in your mind. So now comes some concepts like VMware or virtual machine, I would say, then your Docker container, and then your microVMs, basically version or basically the same thing as VM only. Because here, this user service, think in such a way, you have your EC2 instance or whatever instance it is at this point. It could be your ECS also, ECS run via EC2 or Fargate. That's not a big deal. Big deal is here, how do you run the code? Till now, whatever HLD or high-level design we have seen for every other system, the code is already written by the developers and pushed. And that has been compiled and it is running on the server. But in this case, a code is coming from the user and then it has to be compiled into the system. based on like what kind of it is C++, then obviously it has to be compiled, and if it is Python, then it has to be interpreted. I'm not going into that nitty-gritty details. I hope that makes sense. The point is, you already have your own piece of code, like from a developer's perspective, which are pushed and doing its task after compilation, and then there are code coming from the user which has to be run in an isolated format. The main reason isolation is very important is from a security perspective. If there is any malintention by the user, or is there any problem in the way code is written because of negligence of the user, it can easily eat up your resources. A while loop which does nothing is easy enough to like permanently take away one thread entirely for this process, and you're gone. Something like a fork bomb, when they write at a C level code and they call fork at a system level, then obviously fork bomb will happen. And similarly, there are multiple exploits like kernel 0 and other exploits that can be written in C or C++ or any supported language, to be honest. And that is where you do not want to run it directly into a system service as well. For example, if I were to do, without thinking much, in Python, what I would have done is I would have done a subprocess call, and in that subprocess I would have passed this exact code. I'm not going into the exact syntax, or let me just write it properly for you guys' sake. In Python, basically there is a library subprocess. You just take it subprocess and then write dot run, and then you have multiple arguments that you pass. One would be the actual exactly the binary that you want to run. So if let's say I want to run Python, okay, in Python we are running, let's say, C++. This will be the binary execution file. In this case it is, I'm very sorry over here, I kind of forgot, it is supposed to be G++. That's what and then you will have, now this will, or in case you guys have done your C++ courses in college time, then this is the format optimization level that we are putting. So it's O3 format, and then we will pass the exact code or file, code file, whatever you say, and then the binary output. So this is the compilation step, and you will be obviously doing capture output true. And then also, I think, yeah, timeout variable we will be putting. So let's say I'm giving 10 seconds, 10.0, and I guess this should be fine. The next part would be, again, I will be doing another subprocess.run, because at this point, I have only compiled. This was the compilation step. Now I will be doing the same subprocess.run, but now I will be passing my binary output path. So binary output path, and I will be providing my input. It will be my input path, and then finally again capture output equals to true, because we need to capture all the output like compilation error or whatever runtime error has come, in this case compilation error, and in this case runtime error. So again this will be true, and timeout in case it's not responsive, so maybe 3 or 5 seconds, whatever. And there you go. Yeah, if my memory serves right, so this will be in your subprocess.run. And finally there will also be an evaluation. I'm not going into the nitty-gritty detail. The main thing I was saying is that what I can do is I can take all this code, I can write a Python file, so it will be my solution submission engine.py, and in that there will be a logic where I will put this part of the code and this part of the code, and all these things will be my variables which I am getting from my get request. But the problem is, in this engine itself, if I am running it, then I can go into these issues. If the code itself is the problem, fork bombing, kernel exploitation, improper looping conditions like unlimited or infinite loops, and furthermore, these will create an issue. So I want to run my code in isolation because of security concerns and protecting my own infrastructure. So remember in mind, this is an example and it will come handy actually. This entire logic that we wrote, this thing will come in one flavor in the isolation process itself. So what do we do now? Think about it. I had drawn a API gateway, and then there was my submission service. Now I'm only talking about service submission. What if I'm able to spawn something like a container, and that is where I said Docker and VM. They are kind of different. I will just like briefly give 5 minutes to it, like Docker and VM from an architectural point of view, and kind of compare which is better. Or maybe something, what that something can be kind of an ephemeral service which spins up for, say, for a given duration, does whatever I want it to do, and then destroys and gives me back the result. Then there is Docker, VM, they are also fulfilling the same thing, and there is this AWS Lambda also. Remember I said that these all things will not go in vain. This is exactly where Lambda will shine. For Docker, it will also become very easy, and VM, actually not the actual VM, I mean not the heavy version of the VM, but a micro VM like Firecracker. A normal trivia is AWS Lambda is also run by Firecracker. When I will be discussing about all of these in just next few minutes, you'll understand that why I chose the term Firecracker, like the exact engine behind AWS Lambda. So, alright, so what is a VM? Think of scenario, or in general, if you guys have been from a computer science background, generally when you have your host OS and let's say this is your Windows. Generally people have Windows laptops, so I'm just trying to build up a scenario or case over here. It will help you guys understand. Now let's say you want to run Ubuntu in your Windows, or let's say GNU. GNU is something at college level. It's a operating system. This is also an operating system. So what you do? You generally go forward with a VM concept. So this is your entire VM. You have your guest OS over here. In this, let me write guest OS. Then you have all the necessary bins and libraries loaded over here. So bins, libs, and then you have your whatever service you want to run in here, the processes. And all of that is actually managed using hypervisor. And why hypervisor? Because again, you take another VM box. Here you put your GNU. So this will be GNU, this will be your Ubuntu. And again, the same, it will have its own bins, libs, and then you have your own services. So this is like the mediator to directly communicate with the host OS resources. And I'm not going into the nitty-gritty details, but you have different formats like hardware assisted. Like in today's generation, we have the hardware assisted virtualization, which is kind of supporting it. Previous generation models were most of like binary translation. So whatever instruction would come from the guest OS, it would be translated in real time by the hypervisor and sent as per the host OS understanding. But today in the hardware assisted virtualization, the instruction that is coming at architecture level or at the CPU level to the guest OS directly gets translated over this host OS. So that is where this comes into picture. But this is not the actual thing. I'm just focusing on what VM is. This actually was the scenario until something like Docker came into the picture. So let me just quickly cut this out and make a partition over here. Yeah. And this is your VM, this is your Docker. What people thought is, why to go for a bloat? This is an actual bloat because until the time you think about it, this guest OS, this is actually like a machine. So when you are loading your guest OS, the entire booting process will happen. The guest OS will load up, it will get understanding of all the file system and different driver codes and everything will load up, and then finally you get access to your like all the services and processes that you want to run in your VM box. We can go one level easier. So Linux from its own box provides concept of namespaces, cgroups. I'll just again give a brief intro of like maybe next 5 minutes on what these are, cgroups. And also you have your secure computing mode, or what we say in short today as seccomp. So to actually give you an understanding, think in this way. We again have our host OS. And now what we do is we have different containers that we build up over here. All of them sharing the same bin and lib. And this is C1, this is C2, this is C3. And here I will put a Docker engine. Now how this is being done, this exact thing, like if you are building a house, then this entire structure, to separate it from the surrounding houses, it's what namespaces is all about. To kind of put it in words, it is actually providing you isolation to trick a process into thinking it has its own dedicated instance of the entire operating system. I'm not going into a deep dive of this at this point, but namespace is something you guys can check. There are different formats of namespacing, like process ID, via the network, via the mounting structure. Like today when you have a WSL2 in Windows, then you will be seeing the way the mounting is happening. After mount, all the necessary things are coming. Again, that is a VM actually in place, but again after the VM there is another namespacing also, namespacing isolation happening at a Linux level. So then you kind of see this kind of structure. Having said that, there is also control groups, because each container that you are running, you want to kind of give more control over it, that these CPU, how much max percentage of CPU cores you want this process to use. This is percentage. Then you have your memory, because you want how much max RAM should be allocated, allowed, and then also disk IO and network. So these all are done using cgroups. And finally you have your secure computation mode, seccomp. So it is like a syscall firewall. Why I'm saying so is because at the end of the day, when you have, so underlying host OS is there, and then you have your kernel drivers. So the way it was written like long back, you have all your driver codes in C. Internally they are doing syscall, and there are different, you do for example syswrite. I'm kind of trying to remember from my C++ days, it has been a long time. Then let's say you do hello and 6. Now in case you guys might be thinking what this is, 6, this is exactly the string size of this. And this is your file descriptor. This is basically representing your sys, I think, yeah, it's your, it's not sys output, it's your standard output. So basically what I'm saying is, I want to trigger a system write into my standard output, that is my terminal, and there I want to print hello, and this is basically a memory copy happening, and I'm specifying how much memory has to be copied. This is the exact byte size, the 6 bytes, which you can count here, 1, 2, 3, 4, 5, 6. So 6 bytes are being copied, and finally it will be printed. That is the level at which you go. So now if you understand how dangerous or how privileged a syscall is, you can do a lot of things using syscall. So that is where you need a seccomp, so that you can filter exactly what syscall, because in syscall you pass exactly the kind of syscalls you want to do. So this will act as a filtering system, and that is what comes from the Docker, because it is built over Linux, and Linux provides all of this. So technically, now that you have understood, let's say coming back to this from where the entire question or discussion started, you have your service over here. All right, the submission request came with the code. You obviously know that you cannot run it over here. So you will have to spawn. What do you spawn up? Do you spawn up a VM or do you spawn up a Docker? From the way or the looks of it, if there were no Docker, then obviously what you will have to do above your server or above your service, you have to spin up multiple VMs. You have to kind of VM1, VM2 as a like this. You have to keep a lot of VMs out there, and then you have to run your code into each of the individual VM. And the moment the code is run, then you have to kind of decommission it. But today that Docker is present. Prerequisite of Docker is Docker can only run if your underlying host OS is your Linux. Then only the entire concept of all these things will work. And then obviously you just have to do a Docker run. Prerequisite is that the image should already be pulled. So let me just bring a small snippet of the code and show how or what you might be exactly running from your service. This is what I was talking about. I will not take time to write it, so I've kind of taken from my VS Code and pasted it. Obviously, see you guys, I'm taking so much time to write the exact code out there. This will actually run if you actually first understand that how the things are happening. The point is, I need a lot of likes and subscribes. Obviously, when you are watching it, please subscribe to this. Tell your friends also to subscribe, and if you really like it, share it with all the fellow engineers out there who want to learn or who really want to understand, because it's not about system designing at scale, it's also about understanding internal parts of it. But again, coming back to the main thing, I will not beg about the likes and subscribes. You guys, if you really like my content, you will do it, hoping for it. And here we go. The main thing to notice is first we are running the docker run command. I'll come to the RM part, but that is mostly about a removable part. We are not providing any network access. Like let's say in the this is actually written in, like the code submission is happening in Python, so we will be running via Python. So inside the code, let's say any outside network call was going to happen to the outside world, like let's say to the Google or anything. So we are cutting that first, network none. We are only giving it the CPU of 0.5 and memory of 5112M, which actually means here we are allowing 50% of one core processing power, and here we are saying 512 MB of RAM, just in case you guys don't know. And then here we are doing the main volume mounting, and why we are doing so is because in our system, so basically this is our own service from where the Docker is getting spawned. So basically the Docker is, as I said, here in this system, this is our server or service. Here I am spawning up the different isolated containers, and now how will the container get to know that what am I talking about? So from the S3 I will be pulling the necessary input. This is the input. Then I have my code submitted that I saw. Then I will create a file and write that code over here. This will be my solution.py. And then there will be output of this execution, because when the code is running, then there will be something coming out of it that I will keep in my sandbox. Now, what is the concept of volume mounting? This is your actual host OS. It has its own file system, FS. Whatever you keep over here, the container, they get access to it. So technically it's a shared file system now. So how do I show sharing? I can show it like this. So this becomes shared. And this is what we say as volume mounting. Even if the container perishes, this volume mount will remain. I'm pretty sure you guys might know about it, but in case any demographic of my audience does not know, it will help them out. So you can skip this part because it will be divided into chapters. So coming back, these are the different volume mounts that we are doing, because my main service is doing the hard task. It is pulling the necessary input from the S3. It is also taking the code submission that we had done, putting it into a file. It knows where the file is kept, so putting that also. And then for the particular sandbox in the format of container that we are opening, the output that we need, we are keeping it also as a volume mount. This is in a read-write format, this is in a read-only format, so on and so forth. Next, we are pulling this image dynamically, but actually what will happen, when I wrote it, I wrote because I wanted to test this entire command, and this will actually work. The main thing is, we already, or from a Leetcode point of view, there will be a specific image, let's say img1, and it will have a lot of supported, like it supports around 12 languages. So all of these will be present in that image when the image has been built overall. So it will not call Python runner latest, rather it will call the custom image. Let's say I'm saying it as image1, which will have all the 12 language binaries inside it already kept. And because it is having that image already, so it will knowingly keep very compressed format in the image, like only necessary functionalities of the language, like Python 2.7, Python 2.8, like it can specify which exact language it is supporting. And finally comes the execution part. So in a bash mode, execute this entire command, -c for the command, and in the string literals is your exact command. So you want to time, because basically the entire thing, how much time did it take? So you are calling the time function, and after that starts the exact main thing. After this -o is the main. You want to output all the time that has been captured in the metrics.txt. Then you are putting a timeout of 2 seconds. Then finally you are doing the Python 3, because your output solution is your code solution submission is in Python. So you're calling your Python 3 binary, and you are writing this or passing this as an argument. So Python 3 will run this file. It will take input. So in case you guys do not know, this is the input pipe, and it will take input from your input.txt, and the output will be done into this sandbox user output.txt. And in case there is any error, then this part will be from the terminal, like in your terminal, whatever is happening, the second output will be happening. This is what this means, the second output will be happening over in the standard error.txt. And finally, when everything is done, then we will be giving the exit code, we'll be echoing it, and we will be putting that also in our sandbox exit.txt. So in general, when we are capturing a lot of things, you generally see when there is compilation error or TLE is because of this time limit, that timeout that we're putting. And Also maybe MLE, that is memory limit exited, or runtime error, or your compilation error. Any of these errors, they will be captured over here in your standard error.txt along with the exit code. You have standard exit codes. I'm not getting into those nitty-gritty details. You guys can check it out. But your container will be doing this part. So you have actually discussed, I have discussed one standard solution in this format. We are ruling out VM actually to begin with, because we would have gone with VM if we did not have the concept of Docker to begin with. And for Docker, prerequisite is that your host OS should be in Linux. So anyways, the service that you will be opening up, where is my box? Yeah, the server that you have, or the service you have, it will be running on your EC2, mostly over your Linux Alpine or those images. So that's not an issue. In today's world, all your base images or the actual instance that we are running on is Linux variant only. So that's not an issue. The other format we could do is, we can go via the concept of AWS Lambda. Now again, what is this? The same thing. Now let me just make it a permanent pen. You have your request coming via the load balancer. What if you do not want to spawn up these Docker containers? You want everything to be managed by AWS. That is when AWS created the concept of Lambda. The Lambda is nothing but a code snippet. I'll do it like this. This is your code snippet. It is being managed by AWS. So this comes under AWS, and you just have to trigger it, and it will finally give an output. The underlying thing about Lambda is that the box in which the Lambda gets executed, this is actually a microVM, because code has to run somewhere, right? So they went with the concept of microVM rather than containers, because AWS has in its Jeopardy, or in its Jeopardy would be a wrong word, it's a negative sense. What I want to mean here is AWS actually is a father of bare metal. It has all the necessary boxes that it has. It will physically partition or logically partition it and want to play around with it. Now in each of the partitions, it will try to cram up as much VMs as possible, because at the end of the day, VM gives you the actual feel that you are running a different kind of OS. And it took that variant of it, like whatever it saw in container, but it removed the bloat of a VM, because the bloat of a VM is a lot of driver calls related to your USB, different drivers, and then the entire grub mode. All of this it destroyed. I'm not going into the direct detail, but what it does is, think about it. It's your instruction pointer. It will load the entire operating system. It will directly load your instruction pointer to the exact place from where the entire OS can start running. And then it will load the necessary bins and libraries into the correct places. And that is how the entire OS starts up in this microVM format. What AWS did is, it created the concept of Lambda over this thing called microVM, which it named as Firecracker. Now, on the Lambda, you just have to trigger this Lambda, and then it will spin up a microVM on demand. So that's why it will take around 5 to, I think the normal code start is around 20 milliseconds. It can go somewhere around 50 milliseconds. Like I have generally seen around 50 milliseconds, so I'm saying 20 to 50 milliseconds. And after 50 milliseconds, very sorry, actually, why sorry? Because this is not cold start time. Cold start time is actually 100 milliseconds. This number you have to keep in mind. Why? Because why Lambda will be ruled out, but it can also be ruled in, depends on what kind of, like what scale you are building in and what non-functional requirements you are kind of adhering to. From cold start point of view, that means when your system or instance has not put any request so far to the Lambda, like a trigger request, then the first trigger request that comes, it takes around 100 milliseconds. Sometimes it goes to 1 second, but generally I've seen 200 milliseconds. This 20 milliseconds is when already one Lambda has been triggered and it is hot and running. Then the next set of Lambda starts coming. Now, Lambda is nothing but a code that has been loaded. I will just show you interface in some time in these pages of the AWS Lambda, and you will start understanding a lot. You just have to do a trigger into the Lambda. The Lambda will be executing your code, and then once it's done, this entire microVM will be teared down, or like it will wait for some cooldown period and then it will be tore down. And you can keep doing this process again and again. And they are being done. So let's say your immediate request came to this Lambda. Even if it gets compromised, this is from AWS side. It has made sure that its own microVM Firecracker, only this part gets obsolete. The other microcracker VM over which this Lambda is running, it will not get obsolete. So even if any exploit has happened, it will only affect one piece. You can do a similar task over here and you can keep it isolated. We're obviously doing the isolation in the Docker container also, but in AWS also you're doing the same isolation. Now, let me just, like, this is an extra section. I'll be talking about the AWS Lambda so that you guys really can understand if you have to implement at your end also how you'll be doing. I'll be just copy pasting here some screenshots that I'm taking from my AWS console. Actually, it's from my organization's AWS console, so I do not want to reveal everything, or I would have given a live demo of it. So I'll just take screenshots and show you exactly what it is. It's a very simple thing. Just to give a very brief overview on how Lambda looks like. At the interface level, you go to your Lambda functions. You have to write the name of the function by which you will be accessing it. I'll come to the code part where you will understand this function name. Then you have runtime environments. You can choose multiple languages here. Mostly they give code editor support for Node, Python, and Ruby. Code editor is simply like in the next step, you choose the architecture. It will be run over your microVM, which is your Firecracker. And permissions, I'm not diving deep, but any of the AWS resources that you have, they require certain permissions from a role perspective, which you can create. There is from template, create a fresh one, or you can write in their editor itself the rules. After you have done, the next step is this. In the editor, you basically implement the code, the Lambda code. Now the main thing is, once you do a deploy, this function is already ingested by AWS now. That means whenever you call or trigger using this function name, the Lambda will be triggered. Obviously, there will be a cold start of around 100 milliseconds, and sometimes it goes to around 1 second, but in general, it will be somewhere at the at 500 millisecond mark. From my personal experience, this is what I have seen when it is the first time cold time. And obviously, once you have done a deploy and you go back, this is the exact diagram you will be able to see. I have redacted the exact ARN name and function name because it was from an organization. You just have to add a trigger now. This add trigger is, for example, in S3. I haven't taken a screenshot of that part, but consider in this way: you have an S3 and you want to upload to it, or you have a queue, some item comes into the queue. These will act as your trigger over here, based on which your Lambda will be kicked in, and then you have a destination, like where exactly from the Lambda you want your output to be. Now, we really don't need a destination and a trigger always. It's basically when you have your internal AWS components via which you want to trigger this Lambda, and then you want to give the output somewhere else, then you follow this entire path, and that's why this graphical structure is present here in the diagram format. Next thing is the code actually. So the main thing here is the event and the context. So basically you have to write the Lambda handler in Python, and you have to provide event and context. Event is the specific thing via which you will get all the necessary stuff. So first, let me go through how I would have written, for example, if I have to run something in a code format. So let's say my okay, for example, now take the Lambda handler. In this case, there will be a driver, there will be a caller function. It's in Python only, so say there's a def, and then you will be doing some stuff here, and then finally you will be calling your and we are using Boto3 client, so you will have your Lambda dot, and then you will be calling the necessary things. It's not Lambda dot, it's I actually will write the exact code snippet below in this page. So this is where you trigger the Lambda. So now you come into the event. All the necessary information is actually present in the event. So there are multiple steps to it. First, you're taking out your source path where the exact code is present, and also the binary executable path where it should be, the compiled executable binary. Next is we have to write the source code to disk. So basically in this path, you're writing whatever code you got, which you can see over here. In the events code part, you got the user code string. So you're taking that user code string and writing it into the source path here in the solution.cpp file. Next, you are compiling it because it is C++ based. So remember when I had told in the sub process, I think, yeah, here. This again, you can pause your screen and take a good look. Here you're doing a G++ minus O3 level third level optimization with the exact binary output where you want it, and you want the capture output to be true because it is a subprocess.run. And similarly, you want a timeout under how much time, like you do not want to take a lot of time for compiling all the necessary things. So this is P1, this is P2. You will see both the code snippets exactly here. So this logic is not wasted away. It actually came handy when writing the Lambda handler. So you have your subprocess.run, again the same G++ and all the things. You can pause the video for some time and take a good look. Once you have done your compilation process, you are just checking the return exit code out of it. If things are correct, then you are saying that we are just cleaning up the source file because we have got our compiled code. Now the next part is we have to run or execute the compiled binary. So it's just that we will start the timing analysis. So we have taken a start time, and then in the main try catch except, like in the try except block, we are doing the subprocess.run. We are stating the binary path, and then we have to give the input, capturing the output true, and giving a timeout whatever we need. And obviously at the end, once the binary has been executed, we are ending. We are again capturing the time. So the difference between start and end here is our runtime. Other than that, we are taking out the standard output, standard error, and exit code all from the capture execute process. Because of the capture output equals to true, we will be getting it from standard out, standard error, and return code. And then finally, obviously, we are not going into an exception. In case we have, then also we will give a time limit exceeded. We can do that. And because of the timeout, there will be a TLE. And the last thing is we are cleaning up all the necessary things, all the things that are no more useful, the source path and the binary path, because obviously this was a compiled output, so we don't need it anymore. And source path was all the code that the user had submitted being copied over here in the source path for the sake of compilation and execution. And obviously we are finally again checking an exit code. So again, you can take a pause at the screen, but what I'm saying is if exit code is not 0, then that means we are getting a runtime error, and we will give the runtime millisecond and the exact standard error output, because obviously 0 is when things are good and otherwise there is an error. If there is in the standard output there is an obviously it matches your expected output, then we will be giving accepted status along with the runtime millisecond, and there is no error message. Otherwise we are giving a wrong answer because obviously expected output. Now this here is just a very high level. Actually, you will not be going via this. You will be doing a diff. Why? Because if you see my expected output, I have written it here for the sake when I was writing code and testing the entire logic out. I wrote expected output 4 because it was normal for one particular snippet or sample. The answer was expected to be 4. But in this case, you are running a series of input sequences, and you will be getting a series of output sequences. You will be trapping or tapping the output sequence into the file, or you will be getting that output here from the standard output also. That's not an issue. And then you will have to run a diff directly to check that the standard output matches the standard expected output, because as I said, there will be multiple test cases, T1, T2, 3, and so on, and you will be running against each of them. Now on Lambda level, you start understanding that Lambda has its own pros and cons. From a pros perspective, you just have to write the implementation logic, and finally you have to do the caller. As I said, I will show below the caller code. Main thing is first we are creating the Lambda client, as I had said, and then this is the payload that we are creating, and then we are passing the payload over here. So in the Lambda client.invoke, you are putting the function name, as I had told earlier, how Lambda or AWS will identify it using a function name. And then I'm not obviously going that AWS ARN resources will be there via your SSO, you will be calling it. It's basically, I'm not going into that detail, but it can identify in your given ARN that this is the particular function name which it has to invoke, and then invocation type. Now, not necessarily like request responses for making it sync mode, but in case you have to make it async, then you can pass here as type event, so it will become async. And finally, sync async, here you can, there is no point of making it async because I'll come to the next part of it. So here you make it sync, then the entire response works. It will wait till the time this lambda is invoked. This part, these two things, basically it goes over here. This entire code is one block. I broke it down. This entire lambda kicks in, invokes, and then you finally get your JSON dump in this format. Its status accepted runtime along with the standard output, and there you go. So from this overall, what you guys have understood, or what I tried to teach you why this is, you had your submission service. User had given your submission. This is your submission service, and then it has choice one: you spawn up Docker, or else you spawn up, it's not spin up, it's basically providing the same thing to AWS Lambda symbol. I'm drawing it in this way. Now there is also a third variation. This I will consider as an extra content at this point. This is generally when you are supposed to do, I will prefer to go, if you have to build tomorrow a new Leetcode kind of system or online judging system, you go by the Docker concept. AWS Lambda is mainly because of the cold start of 500 ms. Most of the time your system will not be under load. The moment it requires new AWS Lambda instances, it will take 500 milliseconds. Now on an already active instance, you can keep bombarding with requests, not an issue. But again, Lambda comes with a caveat of it will be off, like ideal time is only 14 minutes. I kind of forgot about it, but there is an ideal T minute time, and after T minutes it will again cool off, so you don't have an AWS Lambda instance running on your Firecracker VM. AWS will again take some time. So ideally it's not a good scenario. You can do for the sake of, like, let's say you have AWS free credits or you want to explore around, please go ahead and do it. You have all that code necessary. You can pause the screen when I was explaining or showing the code. You can try it out, it will work. But your ideal way should be going via Docker. But what you will understand from this diagram at this point of view is there are multiple requests coming and all of it is in kind of a sync mode. Why? Because your system has run either, let's say, Docker or let's say AWS Lambda call. It will be waiting on that call. There is no concept of submission in the real sense that it has been submitted. And obviously now the word queue also will come naturally to you because you're submitting, and eventually your submitted request will get served via the worker and the judgment will happen. Basically it will spin up a Docker and then your code will go, basically it will go into S3 and will be pulled by all those similar thing. So that means at this point you cannot just directly spin it up. You have to absorb the request, you have to respond back with a 202, and then you have to submit it to a queue. It can be Kafka or SQS. I'll come to that, what exactly it should be. And then again there will be a submission service here. So this is not the submission service actually. It's normally your receiving end. It's just accepting the request and writing to your DB. I'll draw the concrete diagrams at this point in just some time. And then it is going to your queue. It is writing to the DB, and then it is writing, because here you need to generate an ID for the submission, and that same submission ID along with 202 you are returning to the user, and then you are submitting it back to the queue. Then the queue at its own pace, there will be workers scaled up over here, similarly multiple workers, and then they spawn up their Docker container. So I'm doing Docker over here, and then once it is done, it will return back the answer over here, and it will enter, or it will create and update and entry into the same table that for the submissions you had taken. Now another question remains also as part of it is a NoSQL table or a SQL table. I will discuss about this after kind of drawing the same thing in a concrete fashion. So there will be a kind of a video cut and I will be drawing a cleaner diagram in this area. And here we go. So I'll just again give a brief, but this time step by step follow what is going to happen. You have your submission service. Your initial request to submit the code comes over here, the post API that we had seen. And then for which first thing is we will create an entry immediately in our SQL or DynamoDB, whatever, SQL, NoSQL, irrespective. We create an entry. For the sake of example, I'm just taking a SQL entry over here. The moment I create an entry, I will get a submission ID for it. This is the same submission ID that I will be returning back with a 202. That entity has been created, but it is yet to be worked on. Then after, so this is my step 1, this is my step 2. Let me number it using my pen. This is step 1, this is your step 2. This has to be done first. Why? Because if you create an entry into the queue but you are not able to do this entry into the table, then it's a dead hanging object. Because now, next when the judge works on it, it has to submit back what happened, because there are other columns. If you take a look into the submission, there is a status for the submission over here. If you see, there are verdict, runtime, memory, all these things. This will be done by the judge. So you take the judge. A lot of things will be coming from the judge itself. So this update has to be provided. And even when you are doing a poll here, like polling for submission status, even then your service will be actually querying the main DB, not the judge workers and all. So this entry has to be created first, and then this content will be put into the queue. Now in this case, I had said whether Kafka or SQS. We will actually go forward with SQS because we need a lightweight queue. We do not need a very heavyweight where concept of offset and topic consumption comes into picture, because we really don't want durability in this scenario. Obviously SQS is also durable, it's not that the case, but Kafka is a heavy hitter. since it has a high retention period of the topics, and then there are offsets, it's literally into the file system, it will be storing all the things. You do not need that. These are just job requests that are coming. Even if SQS crashes due to any reason, a simple cron job over the DB can again refill the SQS. That's not an issue. And if you have seen the product of such things like Leetcode and other competitive exams, not exams, sorry, other problem solving platforms, even if let's say your particular submission did not run because it did not get inserted into the SQS, or because of any reason the SQS collapsed, this submission is a one-time failure. Again, another SQS will spin up and you will anyways make a submission request. That's not an issue over here. Obviously, from a competition perspective, I will come here. This is a normal scenario, whatever I'm discussing about. This is not equivalent to competition. Why? I'll discuss about it in just some time. The main reason is, or right now I will not go into this logic, but rather what I was fulfilling here. The next steps will be, from the queue, the judge worker will be picking up and start consuming at its own pace individual message packets. The message will have all the necessary info. At this point, you have understood that the code that was going to be submitted from the user, so that there is no bloat in the table. And also in the API request that we are passing around, all the different components, we do not want heavy packets to be roaming around. The code will be immediately stored in the S3. Now the judge worker, when it has to, I forgot to draw this line, but it has to also communicate with S3. And it has to pull that information the moment it consumes one particular packet. The code it has to take in, and for the respective, it will also communicate with the DB. It will pull that, because remember the problem table. Let me again scroll up and show you. So the problem, it has all the test cases over here. So from the test cases, the input path, again, these are also S3 URLs. And this will be pulled up from the test case scenario perspective for that particular problem. And then all of it will be passed around here. And then the container, yeah, I'm correct, Ben. So your containers, individual Docker containers. So every judge worker can scale up independently, and each worker can spawn up as many Docker container it can as per its capacity constraint. And accordingly, the load will be like the worker, the consumer load can be taken up. And here we will be going with ECS, because obviously we want scalable solution. And because we are spinning up Docker containers, we have to do it using EC2 only. It won't be possible in Fargate to spin up Docker containers, because Fargate is completely AWS managed. So they do not want a Docker above a Docker. I mean, it's kind of a high level abstraction that will start happening. Fargate is not actually Docker, but there is a machine which they are virtually dividing. But in EC2 case, it will behave like your machine that you have already. So then you will be able to spin up. Generally, in other scenarios, I do not go in this deep, because you can choose any variation of it when you are choosing ECS. So let me write that down also here as well, ECS with the flavor of EC2. And finally, when you get back the output, like the judge will do the evaluation, obviously. And once it has got the output, it will submit that, or it will update this entity that we had just created over here. It will update it using the submission ID that it already was tracking. And now when next poll will come, like which is happening every 2 minutes or so, every 1 minute also, you can put that granularity, you can decide 1 to 2 minutes, or every 50 seconds or every 30 seconds also. It's completely normal to do a polling in this case, because in case you are not actively looking at the submission, it will eventually do its task and submit the solutions over here. So once you have got that, in the next poll, it will get all the related entry. It will convert the status into, so basically from pending, it will be converted into completed. And after completed, you basically check for all the necessary things like the runtime, execution, errors, all those things. And you have a very happy path of your submission at this point. You have basically take a pat on your back that you have survived the video so far and completed a submission of the code, and you have got the result. Now comes the leaderboard thing. Basically, when you are creating, sorry, it kind of went over there. So basically, when you are doing a contest, you have to go with the leaderboard concept that we have kept as part of our functional requirements. So to give a gist of it, let's say 100,000 users, or now let me use a durable pen, 100,000 users are coming at a time for a 90-minute contest. There will be like, let's say 10 questions, and all of them are submitting their solutions. So your instance is picking up a very high level load. First part is making submissions. Submissions have to run. You also check live leaderboard. So how I will narrate the story is, we have already done the submission, but think in this way. Your Leetcode platform is there. You are a normal user, and this is a Leetcode contestant. They both are making submissions. You are not part of a contest. This person is part of a contest. They both are submitting. And our submission pipeline so far, what we have built over here, it is not distinguishing between a contestant and a non-contestant. So your SQS starts choking up with all the requests. It kind of homogenizes where we should differentiate between different kind of contests. We have not done so. And also at the same time, I had shown that in a 90-minute duration, the last 10 minutes and the first 10 minutes are very heavy hitting. Specifically, the first 10 minutes are also very hitting, and specifically the last 10 minutes, because everyone, even the one who is not serious, they also will give a shot and kind of start submitting. So all your heavy 100,000 requests, out of which like around 1,000 requests per second kind of load you will start getting. You will have to scale up your workers also. So this entire discussion I will be doing as part of this leaderboard thing. So let me write it cleanly now. Before I talk about leaderboard, I want to talk about different competitions. This is also a reason why a separate leaderboard service should be present to manage various style of competitions. There are actually different flavors of competition, and by flavor we mean different scoring mechanisms. Mostly the two famous ones are ICPC, sorry, wrong pen, but yeah, one is ICPC and one is IOI. I kind of forgot the full form of ICPC, but for IOI it is International Olympiad of Informatics. It's meant for K-12 students and below, and I'll come to like how the pattern or like scoring pattern is different. Here in ICPC, it's all about scores are equivalent to number of problems solved, so number of problems solved. And otherwise, for breaking tie, let's say two people have scored 10 and 10. How do you break the tie? You check total penalty time. So what is the meaning of penalty time? For every wrong answer, like there are two cases, one is accepted and one is wrong answer. Wrong answer is basically when you are submitting the solution and any of the test cases is failing, then it is equivalent to a wrong answer. And obviously we drew here the judge. This judge will be emitting the status wrong answer or accepted, all those things. So on that you get a penalty, let's say of plus 10 minutes. So technically, let's say there are three people, P1, P2, P3, and he has scored two questions. Like there are Q1, Q2, Q3. This person has got AC in this. First did in the first 5 minutes. I mean, here the time actually does not matter because the way the tie-up is happening is because of penalty time. But at the same time, the time exactly when it is submitted also matters. I'll come to this part. And if number of problems solved is equal and total penalty time is also equal when the problem was submitted. I am not sure at this point. I'm not able to remember that in ICPC if this is applied or not, or otherwise they give the same rank. But at least in Leetcode, all the three things are there. So let's say Q1 is AC for P1, it is WA for P2, and P3 could not solve it. Now this is also AC for P1, but it is after like 1 WA. This is an AC for P2, and this is an AC for P2, or let's say WA. Could not solve also. This is a poor fellow. And this one is an AC for P1. This is a AC for P1, for P2. Let me make this one as an AC. And he solved it in minute 10th minute. And he got an AC. Let's say for every AC you get plus 10. So P1 is getting plus 10, plus 10, plus 10, 30. P2 is also getting 30. And P3 is getting only 10. At the same time, if you want to break tie between P1 and P2, just see, he did a WA first and then an AC. For obvious reason. Only you can get an, I mean, if you have got an AC, like answer is accepted, and then you do a WA, it doesn't matter. But in case you have not got an AC so far, but you are making a WA till then this gets added up, and let's say we are adding 10 minutes as penalty time. So there is a 10-minute penalty that P2 has got, P1 has got. Whereas he did an AC in the 20th minute. And let's say the entire competition is of 90 minutes. Even though he has solved the Q2 late, still it doesn't matter because here when the tie is getting broken, they both have same score and he has a penalty. So P2 gets ranked up. So final ranking will be P2, P1 and P3. Whereas for IOI, entire discussion that we did was for ICPC, and for IOI it's very simple. There is partial credit. It's equivalent to, in case you guys remember, or if you guys don't know, there used to be Google CodeJam. So CodeJam took this scoring mechanism. CodeJam was my favorite during my college days. I would take part every year in it. It got discontinued, I think 3 or 4 years back, I'm not sure. So CodeJam took the inspiration from here. So basically you have partial credits. So let's say there are 10 test cases. If you're able to solve 5 test cases, you get +1, or like whatever ranking mechanism, scoring mechanisms, that you get +10 for each of the 5. So max score is 50, and for +10 for each, so max score is 100. You scored 50 out of it. Someone scored 100 out of 100. There is no penalty for wrong attempts, so I would say no penalty. And score is equal to, at the end of the day, sum of points. That's it. It's pretty straightforward how one could design a competition. ICPC is the tricky one. The main reason is IOI is for school students, and it happens on an interval of 5 hours, I think on day 1 and 5 hours on day 2. Obviously, I mean, kind of wanted to take part in it, but again, it's another story. But yeah. So now why I've introduced about these two styles is because now you understand. Let me just copy some part of this diagram from here. I think I'll copy this, and let me go to a clean slate and paste it over here. The main reason I wanted to copy over here is, you see this submission, right? It has given to the queue, and then the judge has worked on it, whatever results came from the containers. Now, because there are different variations and flavors of how the thing is getting scored, and also it needs to be tracked because judge's only work is to spin up containers and get the result and update in the DB. There will be a separate service for leaderboard. Now, the leaderboard, judge will also have to update to the leaderboard, and then when the player is querying, it will query for, like, remember the get query for the leaderboard, like contest ID and then leaderboard. This request will also come to the leaderboard. There will be a database, I mean the same DB, where we will be querying what is the exact ranking. So here I will be discussing in combination that how we are storing, either is it SQL or no SQL, because think about it, all your things are in the submissions table, the scheme that I had shown earlier. Now submissions is growing. If we store it in a SQL way, then how do we do query ranking? And basically, how do we store it so that we can query very fast the ranking? And when you store it in a NoSQL format, how do we do a ranking? And can we optimize further? Obviously, I mean, cache and all can be introduced in front of it. And because it is leaderboard, something should strike you is that there is the concept of Redis cache for leaderboard as well. But the point is, it's easier said than done. Why we introduce Redis cache as a leaderboard? We need to understand it comes under a domain of top K, which you can check out in the top right as a linked video to my discussion on top K as part of your Spotify and other in general. But at the same time, we can also, it depends continuously on the load. Like 100,000 users during competition is when you have to think that what are the trade-offs. So this time in the system design, I want to talk about all the formats possible and then finally come up with a simple, elegant solution. It's not simple, but okay, it's an elegant solution. So let me start drawing it out. At this point, there is a leaderboard service. The next thing would be a request for the leaderboard will be coming to this leaderboard service now. Now it's the same DB. I'm just drawing it over here because arrows will otherwise go from here to here and it will pollute the table. But it's the same DB. So putting that marker over here, DB, and then a query will be done over here. Why? I mean, the main reason is simple. All the submissions that are coming now, which have been done by the judge. Anyways, the judge is updating the DB. Like we have our submission table. We are taking case 1 right now. Consider it like I've already started discussing also parallelly about SQL versus NoSQL at the same time. This is like I cannot exactly divide it between two different topics. It's the same thing. It's like the moment I have differentiated and created a new leaderboard service, my read requests are coming to the leaderboard, and then the leaderboard will be querying the DB. If it is SQL, like case 1, I want to show that sometimes what happens, many people think that because, oh my god, there are 100,000 requests coming at a given time, then I want to do my query, I will have to do it over a NoSQL DB only. It's not the case. I have also read recently that how ChatGPT was able to do it using PostgreSQL and using only one master node. So how is ChatGPT able to do? That means Postgres has a lot of power buttons in it. It's just that we need to know how to do it. But then I will also give strong arguments for NoSQL as well, that why in general people go for NoSQL instead of SQL, that what and all hard work you have to actually do over SQL just so that you can maintain and bring it to full power. Now, if it were in SQL format, then we already had our submission schema table, which you can go back in the video where I was discussing about the schema. So I kind of played around with the SQL query, and this is the SQL query that I kind of saw is working fine. So the very important thing is, I have also told earlier in the scoring mechanism that only when you have done AC, then the WAs will be counted as penalty. In case you have not got any AC for, let's say this is question 4, you did not get any AC for it, then even if you are doing a lot of wrong submissions, it doesn't matter. Only if you got an AC, and then all the WAs before it will be taken into consideration. So first, we just need to get to understand the first AC. Yeah, I think penalty is correct. The first AC means the first time when we got a correct submission, then we will do a penalty calculation, and finally we will take these all things and we will do a sum over it. How to understand a query on a high level. Writing a query, it takes some skill set. I have been doing it for a long time, but if I want to really explain, or even if you want to understand, directly come to the select statement and start seeing. See from the bottom up. In bottom you are seeing you are ordering by number of solved problems, descending mode. So because you want to rank in this way, someone has solved 10 problems, someone has solved 10 problems, someone has solved 9 problems. So obviously this is descending format. Now you want to put total penalty as ascending. Why? Because say this guy got a penalty of 10 minutes, this guy got a penalty of 20 minutes, and now you have got your proper ranking. This is R1, R2, R3, where R supposes the rank, and then 1 is like the top rank. This is the first rank, second rank, third rank. Now, in this we have our user ID, which we are anyways getting. The thing is, we want to count the total problem ID as number of solved problems that we have already got problem ID. And how are we calculating the exact penalty? We are considering for every wrong attempt we are adding up 20 minutes. So here it will be 20, and let's say here it is some multiple of 20, so 40. Basic maths. We are taking the AC minutes the first time plus the wrong attempts before the AC into 20 as the total penalty. I mean 20 plus there will be some X. This is the first time when something got submitted, and also this is Y, something when got submitted. But the main thing is this penalty that we are putting as the total penalty. Now you start thinking that how these have been calculated. Do you see anything like AC minutes that was present in our schema table? If you go back and take a look at the table, there was nothing called AC minutes actually in this. Then how do we calculate the AC minutes? And similarly, wrong attempts before AC. These two things have to be calculated out. And now if you search for AC minutes, you can see the occurrence over here, AC minutes, and then over here AC minutes. Similarly, for wrong attempted before AC, you can directly get it over here. Now you start understanding, like first you see AC minutes itself, that how it has been calculated. What you are doing is very simple. You are taking out the user ID, problem ID. You are grouping by user problem ID, because one user can do multiple submission. Let's say user 1, they do problem 1 2 times, and then problem 2, and then problem 3. So you want to group user and per. So all of this come up in your table like this. So when you do a grouping, now you will get unique groups of U1, P1, U1, P2, and U1, P3. I will keep this area short because really I don't want to take time in discussing about the SQL, but at the same time, in case you guys are not aware, because you can do all of it via one SQL query and get the ranking. So that means SQL will work. This is a proof itself. So where I was explaining this part of grouping by. Once you have made the group, the first thing you want to understand is get the minimum submission time that will act as the first AC. Condition is, main thing is the competition ID. You want to filter out, because in the submissions you do not consider about other submissions unless it is part of the competition ID we are talking about. And the status is AC. Once these things, and obviously from the submissions table, once these two criteria have been met, then you take the timestamp difference of the minimum submitted at, like all the solutions of problem 1 that got submitted, out of the one which is accepted, you take the minimum one. And since when the competition started, you take the difference, that is a timestamp diff, and that is your AC minutes. Like when exactly, since the time the competition started, let's say start, and this is when question 1 or problem 1 got submitted. Then you get your plus X from here. As simple as it gets. Now, this is your one table that got created via this. Now you take penalty calculation into consideration. You have to do a join. Basically, from all the information that came over here, you are doing two table joining. One table you create over here from first ACF, and then you join it again on the submission table, because this is a filtered table of AC. You again join back on the bigger table to identify along with the wrong problem. How you are doing the joining? You are matching the user ID for doing the join, and when you are doing this join, you are matching a lot of other things. You are matching the problem ID, the competition ID, obviously. Status this time is wrong answers, because let's say problem 1 has a WA and then an AC. Via filter you got a AC first, and then via this part you get a WA first. Now you are doing these two joins, and ultimately what you are trying to find out, the number of submissions that happened, because now you're matching all those problems which also had a, so P1 had an AC which you got over here, and then you also see that it has a WA. So now you start counting how many submissions happened which were of format WA. So let's say there were two P1s, like two submissions that happened as WA. Now they will be counted here. Output of 2 will come over here. So now your calculation will be 2 into 20 plus already the X that you got over here, and that is how the entire thing got calculated, and then also the ranking also happened. That means this is very much easily possible from here. So is SQL a good candidate? Yes, it is. Now we have to start considering the numbers that have been put forward to us, and this is the first time where I can actually start justifying the non-functional requirements coming into picture. Generally, I see many places people start doing calculation back of the envelope and all. I generally don't do it, and I have never seen it being any favorable. But this is a place where even without doing back of the envelope calculation, you start understanding how things start getting problematic, because it is a table. This table is growing. All the submissions are coming at one place. We will start thinking from not even going into the structure itself. We will start seeing that what is happening at a competition level. When 100,000 users are submitting at given time, then a lot of hammering is happening from here itself. Like from the judge, a lot of writes are happening on the DB as submissions keep coming, specifically in the first 10 minutes and the last 10 minutes that I had already explained. Every write that is happening, you need a active connection to it. You cannot maintain like around 1,000 or 100,000 or 10,000 connections actually in one shot. Like you are just exhausting the IO resources of this DB server. You have to put a PG bouncer to begin with. So it's basically the PG bouncer is here. How do I draw it? Maybe I'll draw it in this way. This is a PG bouncer. Now the judge will be putting the request over here, and then it will be going over here. Let me just change the color of the pen. So now onward, the judge will be putting the request in the PG bouncer, and then it will be hitting the DB. In case of submission, if it is a SQL DB, only the submissions table, by the way. Now the next part is, still there is a lot of spike over here. We have only taken one thing into consideration, the number of active connections, not the number of writes. Writes are still the same. It's just that the number of connections have been reduced. So the next thing we will be putting up over here is queuing up mechanism. So let me just keep it aside and draw the same part. You have your judge, you have your DB. It's the submission aspect only. You have your PG bouncer. Why this PG bouncer? PG bouncer is basically sitting over here, right in front of the DB. Then you have a queue over here and another worker. This in the queue you are putting, this is your judge. Now a worker is consuming from the queue. Then it will use the PG bouncer's active connection, use it, and then do a write to the DB. These are the two important things that you have solved once you are using DB. The next part is, can you optimize it a bit further? You see, when you are making a write into the submission, your format is insert into a lot of things. Insert into that table a lot of things. The values, this is particular one submission. Similarly, you do it S2, you do it for S3. Now, in a typical ideal scenario, if I were to do it as an engineer, what I would say, hey, what if my worker pulls up 3 or 4 messages, like it batches 20 submissions at a given time, like 20 items from the queue, and just puts all of these, like these values, and do a batch insertion. That way you are not even exhausting. Like for doing one transaction, you just need one connection, one active connection, or like one session connection. So you are requesting very much less resources from your PG bouncer. But the problem here is, because you are doing inserts, you have to manage the time also. So you can do that over here. I'm just saying that the time will be part of the packet over here, the submission packet that is coming from the judge at this point. Then the time in setup will be also here, that submitted at, which you see over here, the submitted at. This is the main thing. But now we have to address the elephant in the room at this point. The table is growing, and the table is growing at a very huge rate. Every day normal submissions are happening, and every month there are 2 competitions happening. So 100,000 into 2, and just take that number and do into 30. That sorry, into 2 is basically in a month, and then into 12 is basically in a year. And for year 1 itself, you have got 24, and then 00, and then 000. I think, yeah, comma format. So it's almost 2.4 million records are at this point. And now think from this perspective. Every year you are appending to this record. Immediately you should start understanding that here we have to play with the concept of partition. Not because it is growing very huge rate, it's because write and read in this kind of a scenario is very problematic. Read happens over indexes. You have to build an indexing properly, and you have to affect only those indexes where you really want to make those writes. And that is where the concept of partitioning came into picture. A lot of this is an append only table, by the way. Once a submission has been done, you are not going to anyways make any modification to a submission. It's never possible. That is where many people proponent it, saying that it should be NoSQL, because it is an append only feature. I have discussed in most of my other HLD videos also, be it metrics collection or top key or any place, when you have an append only nature, NoSQL makes more sense, because you are anyways not complying around with your ACID property in this table anymore. You have done so much engineering hard work, but at the end of the day, you have to also introduce a partitioning concept. So that means once we have, let me complete the entire story over here. And obviously I've said, because most of the data over here is append like already stale, you will have a choice to make a partitioning, time-based partitioning. What you do is, when you are creating the submission, like basically when you are writing the declarative statement, create table submission, blah blah, and obviously all the column names are here, then you put a partition by, and partition by here it makes most sense, what we call range partition. So I'll be putting a range, and till now you must have guessed it, but it should be created at, not submitted at, because I mean submitted and created will be almost same in time, but created at it makes more sense when you're creating the entry in the submission table. So now the main thing is, once you have done by created at, so technically what you are doing is, this is the entire submission table, you are creating subchildren. So just next step after it is, and each of these are basically, so this table that you are creating the submission, this is not actually containing the data. These partitions that you are creating, partition 1, partition 2, and similarly partition 3, these are where the data resides on the RAM initially, and then the flushing to the WAL. Now these are some things that you should start understanding, that how SQLDB works. This is not at all the main focus of this system design, but understanding that the submission table that we created here, this is your submission. Let me actually paste the logic here, which will give you more idea. So now you see what I was trying to say. Here you create a submission table, but you partition it by range, like uncreated at. Then these are the tables that you start creating. Now see, when you're creating the table, you're obviously, you can name it as the way you want, but this is an identifying pattern. We just remove the clutter, and you're doing, it is a partition of the submissions table, and it is based on the values from this range to this range. So now that you are saying 1 month, this is one month range. Similarly here, this is for the month of August, so this is from this range to this range, another 1 month. So now you are taking every 1 month worth of data and you are partitioning it. And when your active competition is happening, let's say right now in the month of July, all your writes will be happening over here. Also coming to the index part on the submission table, very simply put, you will be putting first index, like this is a composite index, you will be putting on the competition ID, obviously. Like how do you decide how to do the indexing? Let's just go back to the main query that we are doing on the leaderboard, and from here you will understand the access query pattern. The main thing is the competition ID pattern that we are putting over here. So automatically competition ID came. Status is the next thing, because obviously we are reading on the status part. Then remember, we are doing a group by on the user and problem ID. So if you can see here, group by user and problem ID, these are the major query access patterns. So you are doing an indexing over all these, and submitted at being the last part. Submitted at being the last part, because when you are doing this query here, where you are doing the min of all the submitted at, then you have to finally order it by all the queries, all the submissions that have happened for this particular user and problem. You take the most minimum one. So you also don't skip that, and you put this. And this is an exhaustive set of your composite index. This is very crucial, where competition ID is not null. The main reason where competition ID is not null is, remember, all your submissions are coming on this submission table. This is your submission. So you have both the types. Submission can be of a competition and not of a competition. This is your general daily practice users, right? So because your daily practice users are also submitting and they are also coming, you really don't put an index where competition ID is, basically you put an index where competition ID is not null. So all the indexes that are getting built from using your B-trees engine, the ones which are part of your daily practice, they will not be going into this indexing, and it will not, because competitions are very heavy hitters. They have to keep banging over here. So this way you are not, this is actually a very smart way, and this will also work on your Postgres. The final thing is, because we are doing partition on the range of time which is created at, we have to do one more optimization over here. I kind of forgot about it. We have to add our submitted at, because Postgres, when the query planner will work, the engine has to plan it optimally. It does not know which partition to go and check into, because we have put our partition based on time range. We have to say it that the created at, or actually you can take the submitted at also at this point. you just put a submitted at here. So it is an and. Sorry for the bad handwriting, but here we go, submitted at, and you do a bound greater than equal to contest start time, and submitted at, again the same thing, less than contest end time. That's it. And now the query planner knows exactly which partition to go and check into. Because of this strict ordering of the range bound, it knows that I have to go and check for this month's partition, and it won't even touch. That is the power that you need to get when you have introduced partition. And this SQL query will work very efficiently, and life will be very easy for you. But because we have already identified that this table has a property that all the submissions, they are on the append-only mode in nature. You are not going and editing or updating any of the previous records. Neither are you going to delete. Before I move on over here, I mean, sorry for jumping, but the last thing that I want to say is, the power of partition also comes that when you have to delete old data, it's very instant. You do not write, or basically you do not do something called delete from submissions, where clause, and all those things, because that is also at the end of the day going and scanning the table and then deleting a particular record and then the readjustment in the B tree. Rather, you just write as simple as drop table, because remember, all these are child tables. These are the actual tables. You have to drop the particular table. So you do a drop table and submissions, and you pass the exact, what we say, that name of the table. So you pass the submission table name. So this way, you are actually saving yourself from a lot of headache, because first millions of rows are getting scanned. Then obviously, again, tons of WAL will be created because of the reshifting and this particular entry getting deleted. A lot of entries actually getting deleted. And then also there will be a lot of bloat that will be left behind. You will have to do a vacuum. These are some terms that you guys will, in case you guys don't know, I will have to create another dedicated video on the entire Postgres and how it works underneath. But it's a very interesting domain. I kind of like talking deep about these things as well. Now that I have discussed about partition and how the case one scenario would work, that when we are going with, the SQL, let's now see that what problems, like, because obviously here I had created the diagram that we had a judge. In the queue we will be pushing, then we will put a PG bouncer over here to reduce the number of connections. We will be batching, so this is our batching. We will take batches of data from here to the worker, like worker will consume it, and we will batch together a lot of things and do one insert at one shot. And our table design also, we will be doing it in a partition format basis. And as we will have a data retention period that after like 1 year or 2 years, we will delete particular set of partitions. So that way we are good to go. Now, because we have already identified that it is an append-only data, we can also think of a NoSQL DB as well. Here we will not go with OLAP and other kind of databases. These are not time series database at the end of the day. So, and we do not want that level of compression as well. This is very simplistic data. We can go with a NoSQL DB of flavor DynamoDB. So I will write it as DDB. So when I'm talking about DynamoDB, first we need to understand the Postgres pane came from basically three things. One is the process per connection, for which we had introduced PG bouncer, a single primary node, or that the main primary via which all the writes are funneling through, and then the index write amplification, and also the bloating that comes, MVCC bloat, but I'm not going to this, forget I said it. Mainly it's the index write amplification. DynamoDB architecture will remove each one by design. Very simply put, DynamoDB, this is managed by AWS. Here there is no concept of connection sockets. It's overall an HTTP API request. You just have to make a HTTP API call to the DynamoDB to get things done. So it's just like every operation is a signed HTTPS. Obviously, there will be an S. A request to an endpoint, like put item, get item, query, all these things. There are no persistent backend processes, no connection slots. Like there is no resource to exhaust. AWS runs a giant fleet behind the endpoint and handles all the multiplexing internally. PG bouncer is just removed from here itself. There is no connection pool to manage. Now, the writes are spread across many nodes. This is the important thing. AWS internal architecture is basically consistent hashing of multiple nodes. That is how it gives a very high availability, and trade-off is lesser or decreased consistency. Now, for this high availability, when we have seen in Postgres, this is one primary node and all your writes are happening over here. In this case, the moment you are putting a put item, the basically equivalent to a write, when you're doing a put item, it is accepted by one of the nodes where it has to fall via the indexing mechanism, and immediately on that it has to happen. But that indexing mechanism is identified using your partition key, the partitioning and sort key concept. So when you are writing in your SQL queries, you have to think about the indexing pattern, how what kind of query accesses are happening. Similarly in DynamoDB also, and I have discussed the same thing in other system design videos as well, you will have to think of the query patterns. And also, once I will be discussing about the query patterns after just some time, the other final thing is the cheaper write path. DynamoDB storage is log structured because it is append oriented only, right? So the data model is much simpler. It doesn't carry the Postgres, that bloating nature of each row versioning, the MVCC format. Because, I mean, obviously, if you think about it, ACID principle has to be maintained and wall write-ahead logs have to be created. So when a row is touched or affected, there are multiple bloats coming into picture. We don't really want all those you can search up this term, MVCC. This is not needed. So that's why DynamoDB supports a lot actually in this case for submissions. Now the main thing is this. So for the partition and sort key, we have to think of the access query patterns. What exactly are we asking for? One is get all submissions for a user, for a given user, or basically a user. I just like to term it in pure English, given user. Then the other one is get a specific submission. And for the leaderboard, you have, I mean, this is submission, you guys can figure it out. And this is the final one for leaderboard, get the leaderboard for a contest. Kind of writing it very fast, so please mind the handwriting. Now, each and every term matters. Why? Because getting the leaderboard is one thing, for a contest is another thing. Getting a specific submission for that particular user is another thing. Getting all submissions for the user, again, I will copy the entire thing here for the given user. Now, based on this query pattern, what we can do is, we can just put our primary key as user ID and our short key as the, how do we name it? Yeah, we can name it in this way. Obviously, there will be multiple terms here, so I'm using this as a delimiter. Then your timestamp, let's say 2026, 7, 12th, because I mean, I was recording this video on 12th. And obviously there will be timestamp, so maybe right now it is 10:30. And then we have our submission ID. This will be our entire sort key. Why? Because think in this way. We are saying that all the submissions, so basically for user 1, 2, 3, in this particular hash ring node, there are multiple nodes. In this node, all the submissions of user 1, 2, 3 will come. Obviously, for some other user 345 also it can come, but we are focusing here. All your submissions will be aggregated in this particular node. And when you are fetching the query of getting all the submissions, then you need a natural ordering. And obviously, it will be resent first. So here you will be doing in this format. This submission has the, obviously this is a string literal, so you will be, the string will be compared as a string literal is done, and your timestamp will be the determining factor, and you will get a natural sorting order. Now for the leaderboard part, before saying this part, why I took a pause here is, in the leaderboard, you see the kind of complex query that we had to do, right? Now this is where you have a major trade-off. In a NoSQL DB, you cannot do a join-based query, or you cannot do a complicated query. It is not meant for a map reduce kind of thing also. So you have to create another entry point into this DynamoDB, which only has leaderboard entry items. So technically you have these kind of a leaderboard entry item. Here you introduce a global secondary index concept. I will kind of introduce you what these all things are, but let me just quickly write the different entry items, then you guys will understand quickly. So this is what I was talking about. So right now the main thing to focus are these and these. Notice here we have a competition ID, and here we don't have a competition ID. So this is your basically the normal practice submission, and this is your competition submission. This will come handy because now for these submissions, and by the way, in case you guys do not know, there is not any concept of table in DynamoDB. All of them go basically, so this content, all of them will keep going into the primary key that we are putting, that is this particular node out of your consistent hashing key. So for the same user ID, all that information is going over in one item. Then using the type, we'll understand that exactly what it is. Now, think in this way, because the downside of a DDB or of a NoSQL database is you cannot do complex join queries. How will you calculate the, or basically here you are doing the leaderboard calculation, right? Not here. Yeah, this entire part. How would you do this over here? As simple as you create another leader entry. First of all, this will be like this, leaderboard entry type. Here also we will go with primary key as user. The sort key will be simple. We will be putting the compressed results of that competition ID that we are putting. That is a normal sort key. The main thing here is the global secondary index that we'll be putting, because a very brief note, global secondary index is basically the same table. There's no concept of table, but if you were to determine it as a table, you have your PK and SK. You kind of create another copy of it, and you determine new PK and SK, PK star and SK star. Now you might be asking that why did not we take this as a PK and SK? I mean the competition ID, and this sort key is the score basically, but I will tell you why it looks kind of a bit different. And immediately by this we will be entering into the score calculation, optimization, and all those leaderboard related things. But first, the main thing is we have to keep updating the score. So this is your score. We have to keep updating. So our query pattern will be get me the user ID, for which right now the competition result, I mean the main thing is get me the user ID, and for that I have to update. So because my primary access, like my service, will have to keep asking my DynamoDB to get me this, where I will make the updates. That's why we have our primary key as the user ID, and then we will have our sort key as obviously the competition result, and then obviously then we create a copy on this and create two more primary key and sort key. Then it will be your competition ID, and your sort key will be the score. Now how this score has been calculated, this is very interesting. Consider this part. There are two parts, before hash and after hash. The after hash is basically the minute, penalty minute. So far, how much has been accumulated? So let's say user 1 has accumulated total 40 plus y minutes of penalty. This will be written here. So this person got 142 minute worth of penalty. This is written as 000 142. And now the actual score part of it. Say the guy has solved 3 questions. We kind of take a bigger number, like let's say 1000, and subtract from it 3. It becomes 997. There is a reason why we are doing this work. Let's say someone has scored only 2 problems. Now 1000 minus 2 is 998. We have inverted it because the other person who scores 998, they will have something in this format, 998, and here their penalty. Automatically you see sorting, so user 1 and user 2, the one who has solved more questions will be sorted higher. Now if we have to do comparison, let's say 001 and 0000142, and someone has 0997, sorry, yeah, 0000140. This means this guy has, guy or girl, whatever, this person has 140 minutes of penalty. So this is a lexicographical sorting. So obviously this will be user 0, user 1, user 2. You will immediately get a proper sorted order. Obviously DynamoDB is not giving you, but when you are bringing it using the sort key, then you will get a direct sorted order fashion because of this global secondary index. Yeah, I mean DynamoDB is giving you out of the box. The point what I want to say is, using the format, the score mechanism, you will be able to do it nicely. And this is also one interesting topic here. But we have not answered the main question, how this score was calculated and put, because here earlier you saw that we wrote this complicated query over here spread into 2 segments, and then we did this. For this we will have to create another entry. This, let me add it in this way here in case you are not able to see. This is your yeah, I mean I have not written the type, but kind of take it as a progress entry. So what will happen is, for every submission that our judge is giving back, this is our leaderboard. Now this is your judge scaled up, and this is your DDB. Now judge will make an entry, so it will create this entry item into the submission, basically update it, and then it will say the leaderboard. Now the leaderboard, what it will do this query. Actually, it does not even need to do this query anymore of bringing this particular submission. It will only do this query. I mean, I was correct. So it will do this query. I will mark it with star, and it will do another query to this entry item. Now, so far for user 42 on problem number 1600, this is the ID. This person has not solved it yet, like has solved or not solved. First time when they are making an entry, let's say for 1600, and it is a wrong attempt, solved will be false, and wrong before AC will be empty. So first time by default it is 0 because this is the first one, or sorry, it will be 1 actually. Our logic will be this entire thing is this plus equal to 1. So by default it is 0, so our first entry will be 1 and solution will be false. So let's get a sequence. Let me explain it. Wrong, wrong, and AC. This is for problem 1. This is for problem 2, wrong. And for problem 3, there is a direct AC. That means for problem 1, this entire thing, first it will be solved as false, and this I will write it as WBAC, wrong before AC, as 1. Still here solved will be false, and wrong before AC will be 2. And the moment we get an AC and it is not solved yet, we will convert the solved to true, and we will do WBAC. There will be no change in WBAC because these all was captured here. Same for here, I won't be repeating it, it's very pretty easy. Your solved will be false, and WBAC for this one will be 1. Here solved will be true, and WBAC is 0. Using this query, the one which I have marked as star, your leaderboard service will be able to calculate the score, and it will keep it will do another query. So this is query 1, this is query 2. First, your leaderboard service ls will do query 1. It will understand that what is the current state of this problem for this particular user 1. Then the next it will do query 2, and it will go and do an updation in this. That way, now there is a load balancer and API gateway. Now when they do a read query of get and leaderboard, obviously I'm not putting the rest of the verbs. So leaderboard, it just has to do a normal query on your this particular entry B, and say that get me in the sorted fashion, which I told and discussed over here, that how the sorting is happening using the sort key of the global secondary index GSI. The main thing is the primary key. So for this particular computation, get me a sorted order. The only caveat here is, because DynamoDB has done such huge work for us at this point, every time the query is called by every user, and they will be doing after every 5 to 10 seconds. Like this is a human behavior when competition is happening, not 5 to 10 seconds, but after every 1 minute, every other person needs to see what the rank is. They will be doing, or some people are like, they will keep like unnecessary, they will even reload or refresh also. But even if you want to keep it live, you just keep your page open and it will keep reloading. So that means after every 5 seconds, your query is hitting here. What you do is, your database, I mean the service, is doing this complicated query. It is not that complicated, but every time this query is happening, and then it is getting responded back to the user. This is what now we want to avoid, and we can actually avoid it. That is not because we have introduced a DynamoDB. We can do the same thing when a SQL is also present, but we have actually transitioned from SQL to DDB at this point of time. And now we will discuss about the actual leaderboard concept using our Redis Z set. It's just like a simple small red component will come over here. All this calculation which happened. So when judge has basically submitted back its result to the leaderboard, it has to make another write to the DDB with all this. It will do, as I said, it will do a query 1, and then it will make an appending and do not append, basically do a query 2 and make the entry change. Similarly, it will also push a write into the Redis this thing, and then all the queries that are coming over here, it will unnecessarily not be concerned with doing your extra query. It will directly be serving from your Redis itself. And the good part is when the Redis collapses, because let's say there is any issue and Redis, like a network partition happened and Redis is no more reachable, it can do a pull query from DDB, fill that information back into Redis as well. It can reconstruct the Redis. Now let's talk about Redis. And after discussing Redis, we will be only left with one topic. I have already introduced that SQS and via which all the submissions were happening over the SQS. I mean, the service was taking it, putting in SQS, then the judge was taking it and scaling itself up, and then in its Docker container. So how will the scaling happen? And also, there are like two different parts. One is the competition, and other is a normal practice user. When the days when competition is happening, you do not want all the submission requests coming into the same queue. Then unnecessary competition will start getting choked. I mean, there will be choke for both practice people as well as the competition registrants as well. So you will have two queues. Then how will the worker differentiate between both the queues? How will the work get queued up and consumed? That is also a separate topic. Yeah, I mean, this video is getting very lengthy at this point. But I mean, this topic looks very simple to begin with. But the problem this topic faces, that system design is not replicated in other concepts actually. Here we have difference of read path, write path and everything. But at the same time, the kind of users that are coming, how the code has to be evaluated. We can then do the leaderboard calculation via SQL and NoSQL path as well. All these things are to be discussed. I feel necessary, so I'm not skipping any of these topics. Before I say about the Redis section, first let's understand so far that what and all we can do given we have saved smartly using these two structures, the leaderboard related parts. The main operations that we want to do related here is updating a score, then get the top K as your ranked leaderboard. So obviously inherently it is ranked. Get a user rank. That means, say I am doing this query, I want to know that am I 101th position or first position, all these things, my rank, and my get user score. Now let's think about it. If we do not have Redis, like as an engineer, you need to think that why do you even need Redis when most of the task is already done? So let's assume for some time Redis does not exist. What you have to do to update a score is as simple as you go over here, and we have already discussed some time back. You do this particular query and here you make an update. For this, you use this first query and make the changes. This will be done. It's easy. Top K leaderboard ranked means you now need to do a query using the global search index. So basically for this particular competition, you want via this sorting key, obviously all the ranks for this competition, I mean all the contestants ranked via the sort key will be fetched. Now you have to, the sorting is actually done, but think from a DynamoDB perspective, the sorting condition that it will apply is lexicographical sorting. So think about it, if there are n items, it will be O n log n. So even if you are not doing the sorting, but DynamoDB itself, again, it will do this only because each comparison will keep happening. So I mean, internally it will happen in n log n time. Once you get an n log n time response over here that you can register. The other is getting a user's rank. Now, how do you get a user's rank? You are not storing any rank over here. So this means, again, you do a top K, you do a full exhaustive 1 to 100,000 query, and then do a linear search over here at this point from the user ID perspective. So it will take n because this is the size n. So your linear search will happen over here. So every time someone does a query, you are spending O n time and O n log n time. I mean, you can cache it for some time, this n log n entry, but it keeps changing. So your cache itself, eviction will happen. I mean, it will become dirty and you have to rewrite. So caching does not really help over here. So that is when you think, can we do something so that when we have something in memory and when I'm inserting it, most of the task is happening at the insertion or the write time itself. When I'm doing query, it becomes almost amortized constant time. That is when you start thinking about the Redis and the Z-set concept. And now that I have established how Z-set came into picture or how you will be naturally able to think about the Z-set, we can quickly deep dive and start seeing that what we have to do. We just have to call for update a score. So I'm doing a parallel, drawing a parallel over here. We just have to call Z add over here. Similarly for top K, at this point, I think with other system design videos, this must have gone on the tip of your tongue, or otherwise in case not, this Z rev range 0 to K minus 1. When you have to do a user's rank, you just have to do Z rev rank. And obviously getting a user score, I mean, you can just query it from the DynamoDB itself, not an issue, or even you can do it from here, Z score. Yeah. And actually to give a full clear syntax, let me just quickly paste here so that I don't waste time in writing it. So this is what I was talking about. Now, one thing to note here is, earlier when you were seeing the score, it was, sorry, it was more like your score had a distinction between the penalty and the actual score using a hash, and it was basically a string literal. But in Redis, you have to put integer for the scoring. Then you kind of take the same idea, and what you do is, you have to basically include both the part, the actual score and also the penalty, into one whole point. So what you do is, you take this number, you multiply it with a very big number, and then you minus the penalty. So how I've calculated it, let's say this person has got penalty of, he has solved 4 questions and he has got a penalty of 300 minutes. I'm doing 4 into 6 zeros minus 300, yeah. So that is what this number is. Similarly, this person has solved 3 questions, and then we are doing. So this way, now when the sorting mechanism happens inside the Redis Z set, it will take care that it will give high priority to the score as well. And when you are doing penalty, so the one who has done less penalty, the decrement will also happen less. And when a tie-up will happen, so say some person has solved 4 questions, other has solved 4 questions, this person got a penalty of 300, this person gets a penalty of 200, this will be obviously ranked higher, this will be ranked lower, because we are decrementing less value. So this is how you kind of like, it's all about binding 2 numbers together completely into one place and then doing the scoring function. So this was the Z add part. Now when you need to get the top 3, and with score and without score, when you put a with score, then you get interleaved results. So Carol with this score, Bob with this score, Alice with this score, all in ranked order. In case you do not put with score, then you only get this. So basically these parts are removed from the result. You directly get the sorted list, or basically the top K people. Here we are doing top 3. Now let's say you want your own, let's say you are Alice and you want your own rank. Here you will get rank as 2. It is 0 based indexing. So when you have to return the rank, you have to basically give display rank is equal to this entire rank plus 1. That way you will get actual rank as 3. And finally, when you really want to get the score, basically you want to display the score, you will do a Z score, you will get this value of Alice, and then your basic fundamental operation would be, first you do by 10 power 6, you take a seal of it. Here you will get roughly answer of, I am sure you will get an answer of 2. Not 2, sorry. The reason I did mistake was it's 10 to the power 5. It should be 10 power 5. Then your seal will give your answer as 3. So now you just have to know, like, this is the number of questions you solved, and the penalty is equal to the same 3 into the 10 power 5 minus this number here. So when you write this, then you will get the difference of 142, and this is your penalty. So you can show both the total number of questions solved as well as the penalty accumulated, and you are done. So at this point, you guys must have understood the operation that is happening. Now we will say that what happens from an operation perspective. This will be log in time. So basically your write is a bit expensive, but then onwards, your top K, this entire thing, every time you query, it will be only log of n plus K, where K is your total number of, the number of ranked users you are finding out. And also finding the user's rank is also very simple. It is only log of n. And obviously score, you will get constant time. So these all are the exact time constants, I mean the time complexity that it will take to fetch the results. At this point, we are almost sorted. For sake of completing the diagram, what I will do is, we had our leaderboard score, we had our scaled judge workers. Even this can be independently scaled, that is not the big deal. This person's request came over here, and it was taken by the submission service. There was a queue. From the queue, it was picked up by the judge worker, and at the same time, an update was done in the DynamoDB. I am writing specifically the submissions table. And then the judge, it spawned up a container. I'll show it like this, inside a dotted box. Then the judge, when it spawned up, it got a response from its container worker, and then it again made an update over here in the DDB on the status of it. And this person, when will do another, because polling is happening, they'll get to know that okay, their question got submitted. The other thing is, for leaderboard, considering this is also a contest that is happening parallelly, it has given to the leaderboard service. I'll just write it as lead, and the other party will understand. Now this will also do a similar entry into the DynamoDB for these 2 entries, this and this. And once it has done so, let me just change the pen color, or else I will draw the DDB over here. Again, it's the same DDB. It is doing an entry, and at the same time we have a Redis. Let me draw that in red color and make an update over here. So I'm doing 2 writes over here as well here, because now the query that is going to be served for leaderboard is going to come by leaderboard, and it will directly hit the Redis and it will give back the answer. So for this reason, so let me draw another pen color. Leaderboard, the query is getting served directly from the Redis itself. We are almost done with it. Now, as I said, there is almost one last part remaining, which is related to the queuing mechanism. This is for the contest queue. And obviously, at this point, you might have understood that when you have 2 different, on the same day itself, when there is a contest happening and then there are general users or who are doing general practice, you cannot pollute it by keeping in one queue every kind of message. Then this contest will be also slowed down, and practice queue will also be unnecessarily choked. So basically, you are doing a practice today, and you will feel the heat by seeing that unnecessarily your time, because you don't know exactly when, like at what queuing order your request has been. Let's say there are already 800 in front of you, and they are yet to be processed because right now a burst of contest submission has happened. So you'll unnecessarily face the heat, which we do not want. So by default, we will have 2 different queues. So let's say we quickly draw 2 queues and name it say SQS contest submission, and here we name it as SQS practice submission. Now again, you have 2 choices: the worker or the ECS, or which we say as judge. You can take and route both the queues. Basically, this judge will consume from both the queues, or you can keep separate scaled up ECS container task containers, or that is, this is J1, this is J2. Each has its own merit and demerit. When you do this kind of a design, then you are just isolating the blast radius. But at the flip side of it, what will happen is, right now when the contest is running, then you see a benefit that okay, Now only your judge 1 isolated for contest submission is working, or basically accepting the task. If something happens at this any reason, this is not down, and most of the chances are that judge 1 will go down due to any reason whatsoever, then judge 2, like normal practice submissions, are not affected. But also you are unnecessarily giving your AWS bills in dollars for ideal time, so you have to scale it down, scale it up. Or otherwise, if you do not really want to go and hit your bills, I mean, I will be a bit judgmental about it because I don't see a problem. I would rather go with this design of isolating the blast radius. But still, if you want, you can put both of them into one set of judge. Like, it does not discriminate. The only way is now we have to, the judge, when it is pulling out the data, it will have to do a rate that for every 3 submissions from the contest submission, it will pull 1. So like somewhere 1:4 or 1:5, so that it is able to empty out the submission from contest as fast as possible, and then it will be emptying it out from the practice submission. That way, the contest pipeline will be much, because there will be more amount of data in the contest pipeline, so it will be able to empty it as in this 5x rate compared to the practice submission. Hope that made sense. I mean, I kind of fumbled in explaining. In case, please forgive me. But yeah, so the next part is how do we scale the judge workers? Again, this is also a sensitive topic. Why? Because one instinctive reaction should be that it should be based on the depth of the queue. But having said that, it's not more than enough. SQS by default provides something called approximate number of messages visible. This, based on this, you can scale up. But there's a problem with this. It goes via the, like, it's coming from your metrics domain. So what is happening is CloudWatch is basically polling. It is polling the SQS metrics. So what happens is, this is your SQS, this is your CloudWatch of AWS. All the metrics are getting pulled into AWS CloudWatch after every 2-3 minutes. I literally see that AWS CloudWatch is kind of slow. It takes around 2 minutes, 1 to 2 minutes, I would say. Then an alarm will be triggered, because again, go and check out my metrics monitoring system, metrics logging monitoring system video. There will be an alarm set that will trigger. That alarm trigger will then lead to the task container, the ECS, scaling up more task containers. This itself, like here, alerting mechanism will take another 30-second lag. And also for the alarm to trigger, in case you guys have forgot, it will be something like queue depth greater than 100 for 2 consecutive periods. Now, what that periods, it's granularity wise, you can take example of, let's say, right now I have seen depth greater than 100, and again in the next poll interval of 1 minute I have seen depth greater than 100. So that will be considered as 2 consecutive periods, and then only the alarm will be triggered. And as I said earlier, if you are on Fargate, because ECS has both the flavors, Fargate as well as EC2, for spinning up or spawning up Docker containers, you would need the EC2 variants. You cannot do it over the Fargate. So EC2, now spinning up EC2 will take one more extra, like I think it will take around 1 minute or so. So if you think about it, 30 seconds here, 1 to 2 minutes over here for the polling part, and again 1 minute, you are wasting around 2.5 to 3 minutes for a thing that already has happened. Like your queue has already got a lot of backlog, and then reaction time is around 2 to 3 minutes. I would say 2 to 3 minutes, a better margin. Already the deed is done. Like you have got a lot of backfill pressure. So generally what happens, I've seen in many people discussing in videos saying that, okay, we will scale up based on the depth of the queue. How will you scale it up on the, on what basis or parameters will you scale it up? You cannot do it based on approx number of member variables in the queue at all. Rather, I would write the word rather. You do 2 things. One, scheduled scaling, beforehand scaling. That is called warm up or warm pods, basically warm up. And other part would be reactive target tracking. It's basically, the reactive target tracking is almost same as targeting the queue depth, but in a much smarter way. And what do we mean by scheduled scaling? It's as simple as, you know that in a month when the contest will be happening. So why not 10 minutes prior to the contest, you increase the target to around 500. You can do that. And mind you, I am going with the concept of having 2 separate isolated scaled up judge workers. So for my contest scheduling, and I kind of go with isolated blast radius, so I will not be giving 1 judge worker. So for this, the way I will be setting up my resource policy, this is your Terraform script. There I will be setting it up very simple. The main thing is schedule. For this schedule, I am saying that my scale target capacity minimum I will keep as 500 task containers, and max capacity I will scale up to 1000. I mean, this can be these numbers can be put as per your stress testing. Once you do it, you will get the exact figures. These are not great things like just putting the name, service, namespace, resource ID, and scalable dimension. So the main thing was that a scheduled scale up will be done. The next part is basically reactive target tracking. That means rather than using the queue depth, what we will do rather is queue depth divided by number of workers. That way we are getting backlog stress. This is more necessary. Let's say this number comes out to be 5. Say because of any reason there are 1000 messages kept in your queue right now because of the depth, and you have around 20 workers already scaled up. This stress is manageable. Again, this number is very hypothetical. It has to be tested out using your stress testing that you as an engineer will be doing about it. Now you will see here, I have put my target value. Again, these are the same things almost here, so don't focus on this. You have the target value. First thing what you are doing is you are gathering your metric, that is in your CloudWatch, what will be going, getting the queue depth. You're putting an ID here just for a unique sequence series. The main thing is this, which is the depth part. You're gathering it and you are basically summing it over. All right. And the next part is, the main thing is calculating the backlog task. Now, obviously, you might be seeing M1 over here. I kind of forgot about M2, so let me paste that quickly over here. Yeah. So this is also metrics. Actually, this will be part of here only. So you see this metrics part. You will be just adding this entire block over here. So this M2 is basically getting the number of running task container count over here. Now, when you do M1 by M2, this is the thing that you want to return. That's why you're keeping your return data true over here. False is because you do not want your scaling metric should not be these and this. That's why it is false. So yeah, that is what I was saying. I will just write it with my normal pen. Here you are doing, rather than depth, you are doing depth by number of tasks or number of workers. This will be your more better accurate metrics. And obviously scheduled scaling. A combination of 1 and 2 is what will help you scale up your worker. So yeah, overall this is the actual picture now. Again, I'll draw the user over here. This was your submission service. Kind of summarizing so far what we have discussed over here. You have all your mostly problem related parts getting served from here when you are searching for the problem and other metadata related things. So these are from your SQL database. It's more than enough. Or even if you are registering for a contest, you can do it. I mean, let's not name it a service of problem. It is some like service A. For submission service, because we have to scale up this part independently, we are putting a different submission service. All the requests will be put up in the SQS. There will be another, as I had said, because there are 2 queues, one for the contest, one for practice. Now you will have 2 different judge workers consuming from 2 different queues. It will be spawning up containers internally. And then the judge, after getting the result back, it will be doing the evaluation, like whatever it is, WA, AC, TLE, whatever it is, it will put it back into the DDB, I mean into the submissions schema. Then the next part is you have your leaderboard over here. This is your leaderboard service. All the queries, these are the get queries of leaderboard related things. They will be coming over here. Obviously, there will be a Redis. And at the same time, an update will also be happening over the DDB as well. And at the same time to the Redis, because this judge worker will be updating over your leaderboard. And when get queries are coming, it will be served from the Redis cache itself using the Z set that we had already discussed earlier. Yep, overall, I mean, if you see about it, this entire thing is very easy. I could have completed in like, let's say 30 minutes. But if you also think about it, there are different aspects of it where I had to prove that it's not like SQL will not do the case. Yes, SQL can also do if you are able to do all the heavy lifting, but in case you do not want to, you can go with DDB. Now, at this point, the video or the topic is complete, but I will put a extra bonus content just after this. If I were to, let's say tomorrow, create a online judge platform for proof of concept or like a startup, I will not actually go with any of it. There is already something called Judge Zero. Links are in the description below. You can check it out. What it does is the exact same thing. Rather, I will isolate this part of it. Yeah. Now, obviously, this will disappear in some time. So this entire segment, this will come from Judge Zero itself. Internally, Judge Zero is not that different. If I were to say it, let me just change the pen color, and this is your Judge Zero box. And it is open source, by the way. So once you host it, it is providing you API endpoints. All the communication related to submission, tracking of leaderboard, every other thing can be done using this. Internally, it is using queue, but it is not using SQS because it's hosted like, so you can understand, it is using the Redis concept of queue. And at the same time, it is having a fleet of workers. And prerequisite for that is it is saying it will use Docker for installing it. And that is where you can understand that internally it is using this Docker. But how is it executing the code? Instead of doing a Docker run that we had discussed earlier, each of its worker, it will call something called isolate. Isolate was actually created as part of IOI itself. The main powerhouse of isolate is it is not going via the Docker daemon. It is just invoking a binary utility directly at the kernel layer. So that's where it is much faster than the Docker daemon process itself. So the Judge Zero can execute a submission and capture the standard out, standard error metrics like within 35 to 40 millisecond itself. That is the benefit you are getting from isolate. And to be honest, you can do the same thing when you are running your own instances in the service itself, in the server here. Rather than doing the Docker spun up, you can do isolate. Like if I'm correct, the simple thing would be you have to call first isolate init, and next part would be just like Docker run, you have to call isolate, then you have to give memory boundation, you have to give the time boundation, and finally you have to call the run and pass the binary, and then the solution, the let's say solution.py file. So it's almost like the inspiration was taken from the Docker run, but it's just that it's not going and touching the Docker daemon itself and rather directly spawning it from the kernel layer itself. Main things are it is spinning up a new PID namespace and network namespace. So basically blocking the internet access, applying a fresh C group or the control group, all these memory and time constraint that you saw that is coming using the control group, specifically the memory constraint. And it sets up a temporary completely blank directory on the disk and restricts the script's visibility so it can see the rest of the host operating system. It cannot see the host operating system. So this is in short Judge Zero. I mean, in case you guys have any doubts or something, you can ask in the comments, but I would say rather explore this part on yourself. I have added the links in the description. And there will be another bonus. So this I will treat as bonus 2. This bonus is about the Firecracker. You know why I'm talking about it? Because I somewhere feel that I want to take advantage of AWS Lambda rather than going with the, what do we say, the cold start time that AWS Lambda provides. Why not replicate the entire way how AWS is managing its own AWS Lambda fleet? I will do the same exactly my way, and I'll get the utmost security, because at a VM level, you get the most level of security. You won't be able to even exploit the kernel, which in Docker is possible, because at the end of the day, you are sharing the kernel space and you can introduce a kernel level exploit as well. So VM will give you that level of isolation. So that too, it is a micro VM, so it won't even take such a huge boot time. So the only thing here you have to do is, you cannot do anymore like your EC2 instance and all. What you have to get from AWS, you have to get something, and that will be your .metal hosts. So in case you're spinning up instances, you will be seeing that there is something called m5.metal. You can check it out on the net. These are your bare metals which you are basically renting out from AWS. And then in that, you have to introduce your root FS system. Most of these things will go, it's beyond the scope of the system design interview. It's basically discussing that we have to create an uncompressed ext4 system, and it will be part of your root FS containing the Python or C++, or in general all the languages. What you have to do is you have to create a AMI format, AWS machine image, yeah. So for that you have to compile all the supported language libraries and then take it and add it into your root FS system, which will be firing up your Firecracker micro VM. Now you have to exactly mimic the same thing. You have to keep a lot of Firecracker VMs up and running, and you have to design your own scheduler. So in this bare metal, you will have multiple Firecracker instances split up. And then from there, whenever you are getting an invocation, you just launch your own, like you already have warmed up Firecracker VM, you just launch your code over here, and the moment it is done, you tear it down. So that way you are basically mimicking AWS Lambda, you're getting the code level isolation, and at the same time, you are able to serve your requests very fast because of the speed of microVM itself. Obviously, I mean, the behind the scenes, you will have a queuing mechanism and other parts. So I'm not touching this because this is a bonus content. Just wanted to say that you can go by the Firecracker, and I think Leetcode might be doing it. It may be not, because when I see Judge 0, it is as simple as whatever we have discussed so far, but instead of an SQS queue, because it is container hosted, self-hosted, so they are using the concept of Redis for realizing the queue. And yeah, I think this was or has been one of my longest videos so far. It took me around 6 days to record it because I had to sit on my free time and do it. So I'm expecting a lot of likes and subscribes. Subscribe to my channel, please, and like this video a lot. Share it with your friends. And yeah, please do tell me what other videos you would like to dissect in terms of system design. For me, system design is not like talking in surface level. It's more like a real engineer talking with another fellow engineer while designing, taking ownership of all the components. So that is why I deep dive. In case you do not like this style, do put it out in the comments. I will kind of adhere to it because I know at times it overwhelms everyone. So yeah, here we go. Meet you in the next video. Till then, take care. Bye.